you always think, oh, filmmaking, render farms, infinite resources. Well,
Yeah.
it was 2010, and 2 GB are reserved for the characters, and we had 2 GB. So the skills that you need to make one of those demos is, algorithmic and programming, low-level assembly stuff. Either have or pair yourself with someone who understands design and music. I was very scared. I was like, oh boy, they're gonna fire me. They're gonna send me back to Europe. Technology and GPUs, the ever growing GPU power, shouldn't necessarily be used to create better shading.
Hello, everyone, and welcome to Wookash Podcast. This time I'm joined by the magician himself, Inigo Quilez. He's an engineer who internalized mathematical equations to such a degree that he's capable of making stunning 3D renders with no geometry, making up and stacking up mathematical functions. He was involved in demoscene, he worked at Pixar, Oculus, and now works at Adobe. He made Shadertoy, and back in the day he was doing visualizations for music in San Francisco clubs during the night after his daily work. It's an incredible conversation, full of energy, high-paced, and just full with technical details from Inigo. So strap in, because it's gonna be a technical one. I would like to start with an overview of your work, because a lot of people that will listen to this probably will not have the fair idea what even is a shader. And then if they will have, they will think, oh, 3D modeling, then you export UV mapping, then you do something, and then
Right.
there's a pipeline, a game engine, and then you come and it's like, no, 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 let's just have some equations. And it's like, okay. So can you
Right.
paint a picture of what you do, for example, in the videos in your channel?
Yes. Well, I do many things, and my real job is more traditional product development, C++, programming, architecting applications, and rendering and stuff. But it is true that I've been, if people know me, some people know me because of what you're talking about, which is a different way of approaching how to render pretty pictures in a computer. So I've been doing this for a long time, but probably the peak of that activity happened when I was at Pixar, where we have to make beautiful pictures for the movies. And at the time, we had a very, very constrained hardware setup, very constrained limitations, and very weak hardware and software. So to the point that I had to render the backgrounds of the movies, including trees, rocks, rivers, mountains, bushes, you call whatever you want. All of that had to be rendered in uh, 2 GB of memory. So you always think, oh, filmmaking, render farms, infinite resources. Well,
Yeah.
it was 2010, and 2 GB are reserved for the characters, and we had 2 GB. Also, it's not like you can buy a new render farm every year, just like you buy a next gen console. These things are investments, and they last there for 10 years. So you might be using something that is 10 years obsolete. Anyway, we had 2 GB, and that's where using a different approach that doesn't involve any of the traditional pipelines, as you are saying. That means not using Blender to make polygons, to put UVs on them, to stamp textures on them, to render them. Instead of going through all of that, which requires a lot of data, a lot of polygons, a lot of textures, I went straight to creating all that content hard coded in the code in C++ through mathematical equations. And I can explain a bit more later if you want, but basically, you were talking of shaders. So what I was doing was the equivalent of a shader, the same approach, in that it's just a mathematical function with some inputs, which might be the coordinates in space of XYZ coordinates of space where you are interested in injecting some content. And the output of the black box, it's kind of functional programming thing, is pixels or maybe some geometry or some colors. And in that sense, it was a shader in that it's stateless, very simple, no access to external data. You just have XYZ coordinates coming in, colors coming out. It just happened to be done in C++ as a RenderMan plugin, which did stress test the RenderMan a lot, and we had to do fixing for it. But so that's where I could prove to myself and to the world that this approach wasn't just a toy or an exercise, a toy approach or an exercise or a fantasy idea of mine of doing content with mathematics as functions of x, y, and z, but that it could be used in real life for a real application as making a movie. But before that, there was a long period of uh, lot of activity leading to that final success where I applied it in real life. Before that, I've been doing this for, I don't know, probably since 2003. So at the time, that would have been, no, earlier actually, 99 or something, probably 10 years of more. And I always was doing all this kind of computer graphics without the traditional pipeline, just using mathematics, mostly in the context of the demoscene,
Yeah.
which is a word that maybe some of the audience don't know, but you being a European probably are aware, that especially in the 90s and the early 2000s, it did start in the 80s, but it's a community, uh, uh, it's mostly a social phenomenon where young developers, not so young anymore, use their computers not to build applications and services and build businesses like American kids do in their garage or used to. They just use they use the computers and their skills to make just pretty things, uh, basically visuals with music, kind of small video clips if you want, but not using tools, but using just a compiler and maybe some pixel art. So it's a bunch of people that have skills in programming, art, music, and so on. And so I was part of that movement, and that's where doing creating content through mathematics and code was useful.
And
Uh,
demoscene, let's just mention that this is like heavily restricted, constrained environment. For example, 4 kilobytes. And you have like four
exactly.
kilobytes for your music, 4 kilobytes
Yeah.
for your graphics, and animation takes like 4 minutes of video, like a clip, and you have 4 kilobytes of memory. And good luck.
Yeah. Well, that is not the only thing that happens in the demo scene. There is also unconstrained demos, and people are allowed
Yeah.
to bring huge MP3 files. Well, I don't know if MP3 exists still, but huge sound files and video, and combine it with and layer it with real-time effects. So that exists. But what you are saying is probably what gets most people's attention from the outside world, from the outside of demo scene, which is the fact that yes, there is at least a couple of categories of competition where people have to submit, as you said, video clips made in 4 kilobytes of data and executable. So it's not like you have 4 kilobytes of data and then a huge engine to decompress, process, and expand that into a video clip. It's really 4 kilobytes of data plus engine and real time and the runtime. So you have to get very creative. It's a combination. You need to apply a combination of skills. One is algorithmic, of course. If there's an algorithm that can output a lot of data from a small amount of from a small seed, then that's better than something that requires you to explicitly create the content and define where everything is in space, for example. So anything that is generative that way is a good algorithm. But then you also need to know low-level programming to the point that, especially at the end of the process of delivering one of these pieces, we are looking at the assembly code all the time. Actually, many of the times we program in assembly. One of the pieces I wrote that still to this day is probably one of the uh, most well-known demo scene 4 kilobyte demos was made in assembly language. And not only you have to be creative but have those skills, but you also have to think of writing assembly language that is going to compress well, because there is a small compressor embedded in the 4 kilobytes runtime that will take the rest, the 4 kilobytes minus 200 bytes of the demo,
Oh,
put it in memory, decompress it, to tag that segment as a code segment, jump the pointer there, and start executing that. So as you write the assembly code, you have to think what will compress well by this mini compressor. And for example, you want to open a window by using the Win32 API, and normally you would do like push the window title, push the x coordinate, push the y coordinate, push the width and the height and the class of the window into the stack. Well, in C you just would pass the parameters, but in assembly you would push the parameters to the stack, call the Win32 API to create window, and then continue. And then after you would do push some parameters, create OpenGL context, and then push, choose pixel format, whatever it is. But knowing how the stack works, you can do things like you push all the parameters of the window creation. You don't call it yet. So rather, it's the other way around, right? You push all the parameters of the choose pixel format, but you don't call it. You push right away in the code all sequentially the parameters of the create
Ah,
OpenGL context. You don't call it. You push all the parameters of the create window context, create window, and then you do call create window, call GL context, and call pixel format. So that means that now the stream of bytes in the machine code, there is a lot of push opcode and then 3 call opcodes, which will compress much better. If you imagine some RLE or some sort of dictionary-based model,
yeah,
uh, context modeling kind of compressor, like Huffman or arithmetic compressors, they will benefit from having a long stream of very
the same.
repetitive
Yeah.
data, right? So you have to go down like that. And you also have to, I remember another trick I used to get the whole thing down to 4 kilobytes with that one demo was that at some point you have floating point numbers in your code to
Yeah.
control the speed of the camera, the trajectories, whatever it is, the color of the sounds. And floating point numbers are not great for compression. And also, normally, when it comes to computer graphics, you often don't need all the precision of a floating point number, of a 32-bit floating point number. That's why we use halves and so on. But in the CPU, excuse me, sorry, what I did was to take all the floating point numbers and make the script to chop the last 16 bits of the floating point number. So basically, the mantissa,
Okay.
so the sign and the exponent were untouched. Uh, and then only the first, what would that be, 23 minus 16, I guess 7 bits of the fractional part of the mantissa were untouched. But the last 16 bits were all zeros. So that would change the colors slightly. No one would ever see it with their eyes. Might change some camera movements and so on. No one saw it. But that allowed the compressor again to find a lot of zeros and do a better job at compressing. So maybe I don't remember exactly the numbers, but it could be something like the last 40 or 50 bytes that I needed to chop from my executable to fit into the 4 kilobyte uh, threshold to apply to the competition were removed by doing these kind of tricks.
This is crazy. And the compressor, you still have written the compressor yourself, right?
I did
Within
not
this.
write the compressor myself, no.
Okay. This
In the
was
demo scene, we use Crinkler. It's a compressor made by a bunch of way smarter than I people who understand compression very. I do understand the basics, and I have written compressors, but not at the level that they do. And
okay.
also, this tool Crinkler is not just a compressor. It's a nice tool that is embedded into Visual Studio. So you can basically replace Visual Studio's link.exe, the linker that takes all the OBJ files and puts them together and resolves symbols and makes the final binary. It replaces that command line tool and impersonates it, and it does the regular linking, but also applies the compression and embeds the decompressing code as well. So I
Okay.
didn't write that part.
Okay, but
Yeah,
you needed to know about it in order
yeah, you need to understand
to prep
how it works, and
the
then
assembly.
so the skills that you need to make one of those demos is algorithmic and programming, low level assembly stuff, and then you have to either have or pair yourself with someone who understands design and music and can make a beautiful piece.
And math,
So
like uh, as opposed like but besides knowing how to program, there's like also the math and knowing what equation will get you
yes, right, right.
somewhere, right? Like this is also a separate thing.
It depends on the team. Like in my case, I tended to do this particular piece. I wouldn't have done it on my own. I work with two people, two demo sceners, and one of them is Stube. I don't know how to pronounce his name exactly, but he's in Epic now, doing amazing work compressing all the meshlets and all the little nanite geometry. So I paired with very smart people who complemented all the things I didn't know how to do. And that's the case usually in the demo scene. You have always teams. I mean, sometimes you have solo programmer who's a bit of, can do everything, but usually it's better to split the work. Yeah,
Have a specialization. I will put the links to your demo things in the description so that people can see them.
sounds good.
Okay, so then you started there, and then you started to develop this idea of making graphics just with math. And
Yes.
at some point, you wanted to make this into like a living tool, like see how it would work, replacing some part of the pipeline, traditional pipeline, or how was it?
Yeah. Well, for the longest time, until 2015, I would say, I had not such ambitions. Like I was seeing myself as a um, not what's the word in English? I don't know. It would be like not an artist, but someone who makes the final product, not someone
Okay.
who makes the tools for someone else to make a final product. So be it demos for the demo scene or films, I was always making the actual things that go to the screen, not making the tools for someone else to do it. So yeah, for the first until 2015, which would be like probably 20 years, almost 20, 15 years, was mostly me having fun with it and exploring the territory of what can be achieved with maths and pushing myself. I remember actually it all started in well the there was a big transition for me at in 2002 no 2001. I was at university, and I'm an electrical engineer, so I didn't study computer science or anything, but um, still it's a technical career. We do a lot of physics and the Maxwell equations and all that, and semiconductors. And at some point, we were studying antennas. This was 2001, so that back when the 1G and the 2G phones were hot, and the Nokias and the Motorola's were taking over the market, and studying antennas was a big thing. So we were studying that, and there were these radiation kind of plots in polar coordinates, where you plot for an antenna or an array of antennas what's the energy that they can radiate or receive, or the
Okay.
sensitivity for every possible angle of incoming uh, information detection. And this was some sort of sine square of phi of phi, I guess, the angle, and they were looking like little butterflies. And that's when it clicked to me like, oh, butterfly, I'm going to try to make a butterfly at home using this equation and see what I can do. And I started with a sine square of phi, and then I started adding, a smaller frequency, well, lower amplitude, higher frequency, like smaller and slower wave to it, another sine to make little undulations on the edge of the wings of the butterfly, and then I added an exponential to push the bottom of the wing a bit downwards. So I started sculpting basically, or painting with mathematical brushes, and 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 I pushed it really far. I could make colors. Actually, this one butterfly made it into a 64 kilobyte demo, uh, from which my team and we won a competition in Spain, a demoscene competition. But that was the first super conscious and attempt to very purposely use math to paint and sculpt, because there's a lot of mathematical art out there in the past, from fractals to all sorts of visualizations of solids, whatnot, that people take a mathematical object and they try to render it in a beautiful way with nice composition and colors and whatnot. So that's more like mathematical art. But that butterfly I was making is like the first, my first, for myself, my first art with mathematics, which is different. The mathematics are not the object; they are just the tool to get to the point. Was the butterfly, not the math. And then I kept pushing that in the context of the on the demo scene. And then um, I used it at Pixar, and that proved to be useful, but still no tools. It was just hard-coded stuff when I used all these techniques in at Pixar. But then 2015, I was part of the Oculus Story Studio, which means which is a little studio we built inside Oculus to with the goal of creating real-time VR films. So 2014 is when Oculus. Actually, I remember interviewing with them. They were showing me the DK1 or the DK2. I think it was the DK2. It had positional 6DoF tracking, and they gave it to me, and they were trying to hire me, right? And they were like trying to impress me with some games and things, and it looked so bad because I was used two things. I was used first of all to Pixar, I mean, I'm gonna correct it. Don't worry, so I'm not gonna get in trouble here. The um, when I joined Pixar, I remember showing them some and trying to use some ray marching, which we can talk about as well, and uh, some of these pixel-based techniques at Pixar to make the vegetation and the trees and the rocks and all that, and it failed completely. So I'm gonna do a bit of a detour here, but I will get back to the
Okay.
to the VR story and to the tools. But um, so when I landed at Pixar and I tried to use my demo scene techniques, it was a total disaster because after 3 or 4 months of working there, all the pixels of the screen were flickering. In the demo scene and probably the games community at the time, we were pretty insensitive to aliasing. Aliasing, it was like, I don't know, that's what things look like. You have pixels in the screen, 320 by 200 of them, maybe 640 if you are lucky. And yeah, pixels, what's the matter? And the people at Pixar were like, no, 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 you cannot have flickering pixels in the big screen going to the
Yeah.
theaters in the world. So I had to basically throw all the work through the window. I was very scared. I was like, "Oh boy, they're gonna fire me. They're gonna send me back to Europe." Because I was in a I was in an H-1B, right? So I was like, "Oh, they don't like anything of what I did." So I had to throw everything and start over by using more native RenderMan native primitives. Not so much hacking array marcher inside the RenderMan shaders, but to use the things that the RenderMan does well and is famous for, which is anti-aliasing, super sampling, motion blur, and all these things. So I had to learn to use those tools. And so basically, all this to say that I learned to hate flickering pixels. I no longer could stand seeing things flickering the screen and instabilities, be it the pixels themselves, be it some specular highlights, be it some normal maps aliasing because they didn't do MIPS, good MIP level on them, or whatever it is. And so they showed me the back to the VR story. I was in Oculus. They were trying to get me into Oculus. They showed me the stuff, and everything was flickering horribly. Like not only the DK2 had a slow resolution, there was very few pixels per degree, I guess. Very low density of pixels, and the color aberration was horrible. So, and then the colors were really bad, right? At the time, displays weren't great, and still today they are not amazing. But whites, the color 255, 255, 255 was like a very middle dark grayish color, gray. It wasn't even white. So the whole thing was a disaster, and I was like, no, I know, I'm not joining. But eventually, the hardware didn't impress me, but the mission did, and I joined. And our goal was to bring Pixar quality content, not necessarily technical quality, but in terms of storytelling and appeal to the VR world, to VR films, and explore what the language of cinematography would be in VR. Because in regular films, you have all these tricks to establish context. You have your establishing shot at the beginning of the sequence with a zoom or a panning camera to show you that you are in a castle or that you are in space. And then it always goes close to the protagonist or to the person. You have a close up to get connection with them, then a bigger one if there's a conversation. So there's all these techniques, and you try not to break things like continuity. If the camera is pointing to the right side of the face and they cut somewhere else and they come back, it's still going to be pointing to the same place. It's not going to move. The camera is not going to move. There's all these tricks, and lighting helps you bring attention to the place of the frame where you want people to be looking at. And so many of those techniques cannot be applied anymore in VR because the user, the viewer, is free to look anywhere. So the whole idea of framing, it's a bit
Yeah.
more complicated. You can try to bring people's attention to a place with putting a spotlight and darkening everything else, perhaps, but then it feels more like theater. So maybe we should use theater techniques and not so much movie techniques. So there was all these things to explore, and my role there was to do the VFX and the lighting. I was the VFX person, and I had a couple of people working, helping with shaders and lighting and textures, and that was great because it was a mix of art and technology. Again, we had these more artistic goals, but the trick was to get those things done in a very limited hardware. We had a GeForce 970, uh,
How
and we
how
had to
much
render 90 FPS.
how much RAM or virtual RAM was
I
this?
don't remember, but I don't know. I'm gonna say 1 gig. I don't know. It was very
That's
poor. It was a very
it's
poor
not
hardware. So
much.
2014,
Yeah.
uh, 2014 that was the year I think. So
Can we
2015 perhaps.
Can we step back a little bit? And you said that at Pixar you were doing this technique with math to render vegetation,
Yes.
and you have a name for this, which is Wonder Moss, right? This is the tool.
Yes.
So can
Yes.
you
Yes.
walk me through like how this tool looked like, how people could use it, what was the
Yeah.
framework within the Pixar,
Hmm.
and then we'll jump into the Oculus world.
Sounds good. Yeah. So yeah. So it was the technology I developed was called Wondermouse. I think Daniel, the lighting DP, the director of photography, called it that way because the first use of it was to create moss. That was for the film Brave, which is the Scottish princess Merida, and about half of the movie happens in the forest outside. And yeah, that was 2011, 2010, and again 2 gigabytes of memory, an old version of RenderMan, no path tracing, no nothing, and there was no way to render. If you imagine moss, the so the production designer told me we want something that doesn't look just like textures applied to the rocks and the trees. We want everything to feel volumetric, very tactile, and we want this sense of lush and very dense and welcoming kind of feeling to it. So I had to go with something volumetric, and I developed Wondermouse for that, and that was the first use of it. Although then we used it for trees and rocks and mountains and other things, but it was not a tool. So that's why I'm saying that up to the Oculus times, there we will talk about tools for the first
Okay.
time in my process. But at Pixar, I was the tool. So the production designer would say, "I want lichen falling from the trees because this sequence is scary." So I would go C++, start a new plugin for RenderMan. I developed a thin layer of not a framework, but a set of little libraries that would help me with the repetitive part of every one of those tasks that I had to do. And there was also a little layer I wrote about sharing memory between the different processes because RenderMan it was using Reyes algorithm. Are you familiar? Is the render everything you ever saw? I think it's a rasterizer, but instead of rasterizing and invoking the shaders in screen space like GPUs do,
Yeah.
it's a renderer that takes the geometry, it dices it into small patches, let's say small squares of polygons, and then it dices those ones into smaller micro polygons. It's a bit like nanite, but 20 years ago. And those micro polygons uh, are tessellated down until they are about the size of a pixel. So you don't want to overshade, right? And also you want to prevent, you have to dice at least twice the size of the pixel to not hit the limit, the Nyquist limit of signal processing. You want to signals to be sampled at least twice higher
Okay.
than what you are visualizing. So well, that was about description, but we had the geometry was diced, and then shading happened in the vertices of those micro polygons, which were still in object space or in world space,
Oh, okay.
and they were shading. We were shading there, so it's like doing vertex shaders only. Imagine a GPU that doesn't do fragment shaders,
Yeah.
just vertex shaders that you have tessellated everything with a tessellation shader, imagine, all the way down so that every polygon is always the size of a pixel, no matter how far it is in the perspective space. So if something is very far in the distance, it will be tessellated less, but still the polygons will be about 1 pixel size.
Was
So
this
that was
more?
what RenderMan does, and that's the only way they could render Jurassic Park and Terminator and all these films
Okay.
in the 80s. They didn't have memory was very limited. So what they did also is all this process of going from geometry to patches to micro polygons, shading the polygons in object space in the vertices, and then splatting those into pixels. All that pipeline was happening over and over again for every tile of the screen. So every 16 by 16 pixels, the whole pipeline would be run a bit like probably like a mobile phone renders these days, so that you would never have to have the whole data set in memory. So you stream data in, you do your frustum calling, tile cooling, discard everything else, take that geometry, dice it, remove the higher order, the higher level primitive out of memory, take the patches, tessellate to dice it to micropolygons, remove the patches, shade those, remove the micropolygons, and splat them. So um, that's how we got the whole thing to render in 2 GB. So the trick was, in our case, we couldn't also have assets because the idea was to do it mathematically, to fit in memory, to fit in our data servers, to reduce transfer from the asset library back to the renderer. So the assets there and somewhere else in another disk in the farm. And also we wanted to reduce per force traffic. Every time you check in and check out an asset, it's a big deal. So if you have, imagine, hundreds of trees and rocks, even if you have 3 trees that you keep rotating and scaling to mimic variety, still a tree at Pixar is not a tree in a game. It has a million polygons, it has been scanned, it has textures, and someone has been, an artist has been 5 days sculpting the thing very lovingly, which is great because it's a waste of performance, but you made someone happy. That's what they like doing, right? These artists got the job because they love sculpting and they put the headphones and they are there in their zone sculpting, and that has value as well. So assets were huge. So the whole point of doing things with math, with my techniques, with the demoscene techniques, was to skip all the data, and also we have a very small sets department. It's not like we had an army of people sculpting, texturing, and dressing square miles and square miles of trees and rocks and bushes. So the math, the the node tool, the code that I wrote, the C++ code, was in charge of generating the assets, be it a tree, moss, or rocks, and then putting them around in the environment according to some basic rules. So I would take things like the, as you can imagine, the basics like the slope and the altitude of the basic terrain mesh, which was a very low poly, very lightweight thing. I could take interpolate the normals and estimate for every point in space what's the normal and the altitude, and based on that, do some kind of shader stuff, the things that you see in Shadertoy or in the demo scene, where, well, if the threshold, if the normal is pointing up, then put some grass. But if it's pointing a bit like that, below 0.00707 or 45 degrees, then no grass, because the grass would slide down, and maybe here we put rocks instead. And also, if the grass is moving with a sine wave like that, but it's on the left side of the hill because the normal dot x is pointing negative, but the wind is coming from the right, well, these things won't move. But the grass that is in the area where the normal is positive x, then we are going to wiggle the amplitude of the sine wave is going to be higher. So that your fake kind of wind is here, but not there. And all these rules also, like, the longer the grass, the older it is, therefore it will be more brown. But the shorter the grass I made it, the shorter the
What?
parabola was, the greener and more saturated the colors would be. So it's slowly C++ing down all the way to creating the sets and the environments. And this was, speaking of hard coding, and I have a whole philosophy we can talk about, not like early abstraction and not building tools unless you're going to repeat the thing more than twice. Well, these days this is a very common philosophy to have, but at the time that was not what Pixar wanted to hear, first of all. So there was a lot of politics I had to to deal with, because people were like, well, why don't you build a tool and then we can replicate this in another movie? And I was like, yeah, but another movie is going to have this kind of ferns and this kind of, no, the next movie is robots and houses. Okay, then we will do something different then. What's to be extracted here, other than maybe a few pieces and the philosophy perhaps. But yeah, I was going to say, I was hardcoding things to the extreme of going per shot adjustments to the code. So the film is made of sequences. Sequences have shots. A shot is normally the space between two camera cuts, and that can be a 3 seconds thing or 2 seconds thing. And some shots required some tweaks, because in this shot, this one blade of grass happens to be crossing the foot of the character. And okay, I'll go there and put an if shot that. It was me and another guy doing it, right? If we had an army of set dressers and engineers, we would make a tool and give them exclusion spheres to put in space and whatnot. But it was awesome, to be honest. It was the most fun I've ever had in my career, because I was doing nerdy things, figuring out math, coding, reporting to production designer, and learning from artists. It was super cool, but super hard coded. So definitely no tools.
Okay. I talked to Aras Pranckevicius,
Yeah.
recently, and he told me that he was on a trip with a couple of engineers from Unity to Pixar at some point, and they were like a little bit scared because like everybody thought that like at Pixar there's all these geniuses and they would be like soaking up this knowledge. And then they met the people from Pixar, and they kind of realized that these are like people that are experienced, but not
Yes.
like geniuses. But also at
Yep.
the same time, everybody at Pixar was saying that you are the genius, the one that is like
No,
capable of coming up with these rules and like making this all up. Now it all like
no, no.
clicks with your like
I'm gonna
story. Like,
correct all of that. No, no, no. You have. I mean, you still have there people like Ben Porter who invented motion blur. You have Steve May, Ed Catmull was until very recently. You do have geniuses not only at the leadership but all the way down. Like I was pretty impressed at Pixar. You are sitting next to a I don't know a set dresser. I was sitting next. Set dresser is someone who uh, makes the environments in gaming. In gaming, they call it creatures and environments. In movies, it's characters and sets. Same thing. So I had the set dressers next to me who are placing and doing the layout of the space and all that. And you see them using Maya and Houdini or whatever, but then they are writing scripts. They know C++, and then you learn that they are the lead in a guitar band and that they also won some ski competition when they were teenagers. And you're like, what? So you have very talented people there. Um, but also, it is true that you have super experienced people. Some people there have been there the whole careers, and you know what? I think I've come to appreciate experience over intelligence. I think I have met lot of very smart people in Facebook, Meta, Adobe, many places, and sometimes it's someone very smart who comes as a new leader, perhaps, and they have been very successful in some other area, in another domain, and they are clearly very smart, meaning they are very quickly able to learn, synthesize, see patterns, and all those things, right? But then they lack the expertise in this particular area they have been tasked at leading, and they do mistakes. They do mistakes that maybe the other guy in the corner who has been there, 30 years and doesn't have the personality perhaps to show they're smart, or maybe they are not as smart, doesn't matter. But those guys do the right thing and they know the right thing to do. And when given an opportunity, they will lead the company or the organization in the right direction. So smartness doesn't always, or intelligence doesn't always impress me that much. I think expertise is almost more interesting. And you can see that also in, I mean, maybe without going off topic, but podcast, right? Like you see all these very smart people, eloquent people talking about things they don't know anything about and spreading misinformation or getting to the wrong conclusions in a very eloquent and convincing way. So have to be careful. But Pixar people, super experienced, and many of them super, super smart as well.
Okay.
And
Well,
what I was doing there was breaking some of the rules, maybe because I was fearless. I didn't have much to lose, right? Kids, mortgages, I didn't have any of that. So I could just, oh, I'm gonna try mathematics here. Let's see what happens.
uh,
It worked out.
nice. So why did you leave and join Oculus team then? Was it what was it?
I think the main reason was it was two or threefold maybe. One was that precisely because of that expertise that people gain at Pixar, the machine, the process, it's a bit of abstract. In the end, it's humans who take all this. I don't like talking about the system and the process and all these things, but it's just natural that people leaders want repeatability, right? So when you are good at something, they are going to try to cast you on the same position or role or a similar one in the future. So the producers, I mean, again, you have to be predictable in your budgets, in your delivery times. The movie cannot be delayed. The theaters were booked, all those things. So there was that risk of not doing maybe grass and moss and trees my whole career, but next movie would have been procedural buildings, and the next one would have been procedural robots, and the next one would have been procedural grass again. So I wanted to try different things. Also, yeah, the tech industry was exciting, and VR. I had worked in VR in the past. So before Pixar, my previous job was in Belgium. I was doing we were in a virtual reality company, and we were building. Um, that was what before VR was focused on consumers. in the 2000s, early 2000s, was focused on enterprise. Like we were building big, together with Silicon Graphics, we were building and setting up caves and reality centers, which are these rooms that big companies like BMW or any engineering or any company that builds things at the time, if they were wealthy enough, they would have a VR room, which would be, I don't know in feet, but maybe 10 by 10 meters or something, and a lot of projectors. And engineers and especially leadership would go there with some VR glasses. They were passive glasses. They didn't have displays, just the fancy blue and red, but without the blue and the red, right? Yeah, some polarized glasses. They would go there to review the new car model or to train into how to. Our users actually were having digital twins of their real factories put in VR space, and then people could walk through the space and learn and train to where the valves were, what was the best escape route in case there was an accident in this area of the factory, and study things like that to get a very visceral and to build a geographical sense of how things would become in real life once built or also after build. And so we were setting those up, and my role there was to build the 3D engine together with Gert and Flavian, uh, who were amazing. I was learning a lot. These were my mentors, basically. Gert Denul and Flavian Brebion, who then went to making a video game about space. I think they released it a few months ago. Super massive procedural space game, battle game, I think. And they were my mentors, but I was in charge of, uh, together with them, of building the VR engine. And it was fun because these were Silicon Graphics machines. And um, they were not PCs. These were the Fuel and the Onyx kind of machines, 64 bits at the time, the early 2000s, 64-bit machines, but they were big endian, and they were funny to program for. And the same machine would have maybe 8 CPUs and 4 GPUs. So the rendering engine, I had to architect it in a way where you would have one resource. The abstraction was that you have one texture, for example, like a programmer, you do my
Right.
renderer or edit RHI create texture, but then under the hood, I would be creating 4 OpenGL handles, one for each one of the 4 OpenGL contexts that drive the 4 textures, but only if the asset was required for that one tile of the screen that GPU was taking care of. We would split the screen in 4 tiles, for example. So it was a fun architectural thing to build, and um, so that was my first VR experience. I worked there for 5 years, I think. I also built a real-time ray tracer. Some of these models that we were visualizing were CAD models, huge. The famous Boeing 777 that made it into a few papers, a few SIGGRAPH papers in the early 2000s. I was one of the people, I think I published at Eurographics. That was my first and last contact with academia. And we can leave that to the side maybe.
Uh,
But I was rendering that huge model, and yes, you can render massive models with OpenGL, but at the time we didn't have. I remember when the first extension came to put vertex buffers in video memory, the vertex array object extension. Before that, we had display lists in old OpenGL that you
okay.
could kind of send geometry to the GPU, but that wasn't very well supported. So OpenGL had trouble to display huge models, even though you were doing your frustum cooling and occlusion queries. It was still difficult. So ray tracing was great because it naturally, once you have a KD tree, it naturally scales logarithmically. Like adding twice as many polygons doesn't really make the renderer twice as slower. It just makes it maybe 1.1 times slower because a search in a KD tree or on a VBH is logarithmic.
Okay.
So I went for a path tracer and ray tracer, and we had a lot of fun implementing those in those machines as well, and achieving scalability and all that. So a lot of low-level SIMD programming. It was super fun. But the main goal was always VR. So when I finally talked to Oculus, I was disappointed by the pixel quality coming from Pixar and having pixel perfect images, and I was disappointed from everything else. Like I had been in good VR where, granted, these were $50,000 setups with projectors and glasses, but the pixel quality, the pixel density was amazing. You have these like 9080 by 1080p screens per, I don't know, 45 degrees. So when you had the whole field of view, you had like an 8K display, which you still today you don't get 8K per eye in a consumer headset. So the quality was amazing. So putting those headsets were like bad, but I was already familiar with VR, and knowing that there was a second, or well, rather a third wave of VR coming to the industry, because before my first experience with VR in the 2000s, the old timers were telling me there had been another one in the 90s. So the Silicon Graphics people that I was interacting with were talking to me about it. And so this was the third wave of VR, but it was consumer based, and they wanted to make pretty pictures. And I was like, okay, I'm going to try something different, but I'm familiar with it. So I jumped in. And also, some of the friends from Pixar jumped in as well, some of them before me, like Max Planck. He was the first one to jump in and to fund this effort and convince Oculus to make this happen. I jumped soon after, and Chris Horn, and then Ramiro, another Spaniard from Pixar, animator, also jumped in, and a few other people. So it was a bit like, I wasn't alone. It was a bit of a family decision. We were all going together, and it was a fun adventure.
So what was the project then at Oculus? What are the goals?
Yes, so the goals were to make those films in real time and learn the cinematography, the language of cinematography in VR. But soon enough, it became, for me particularly, became mostly a technical challenge, like how to render things in real time that don't look very video gamey, whatever that means. But we had expectations about, like, the character had to have fur, and it couldn't be just like 10 billboards with alpha channels and things. It had to be something a bit more sophisticated than that. And eyes, especially the character we were making the film for, his name was Henry. He was a little hedgehog, and he had huge Pixar Disney cartoony eyes, which take 2/3 of the screen because they are huge eyeballs. So you cannot have just like a white sphere with an iris and pupil texture on it. You have to do the proper reflections, occlusion of the eyelid on the eye. The highlights have to be real, but not real, because if you just let physically based lighting to do its thing, the highlights will be in funny places, which can distract. But there's this technique where you always want to have the circular highlight, specular highlight at 3/4 angle, and you have to have a caustic in the opposite direction. So there's all these techniques.
Okay.
Yeah, it's a whole thing, making a expressive character that doesn't look like a zombie. It has its tricks, and the artists know it, and I knew it from Pixar. And so implementing all those things were super fun. So that was my goal, but doing it in a real time. So the first project we made, or second, I think, this Henry character thing, um, was done in an early version of Unreal Engine 4. That was my first time using an engine. And the first thing we did basically was to go into the source code and remove everything and do our own lighting and our own stuff. At the time, Epic was pushing for temporal anti-aliasing, and I was like, yeah, this is going to, we're gonna do this, guys. This is everything's gonna be blurry, and
for
it proved
for
it that way. Especially we had a lot of things for which it wasn't easy to compute motion vectors and
for
track the history
everybody
of the pixel.
for
So
everybody
we
for to interrupt, like, for everybody who is not familiar, like, if you say temporal anti-aliasing, this is like it's like Vim versus Emacs in the graphics world. Okay, like
nice.
this is this level of like problematic aspect. So
I never liked it. I mean, I appreciate it for the service it has provided and all the good things it has done for us, but yeah,
so
it
why
doesn't look
did
good, right? And we can do things to make it better, but at the time it didn't look good at all, at least for us in our application. So we destroyed all the deferred renderer, and we implemented our own um, forward renderer with 8x super sampling, which, by the way, allowed us to do um, some sort of dithered coverage-based transparencies, because you had 8 samples per pixel. You can decide, well, if this surface needs to be 50% transparent, I'm gonna mask the samples as I rasterize, such that 4 of them don't make it to the frame buffer. And then when you resolve the buffer, well, you have 4 out of 8 contribution of that pixel, of that surface to that pixel. So that gives you 50% transparency. So we did some nice low-level tricks like that. by hacking into the engine. And then I also implemented um, my own lighting system. So something interesting at Pixar when I was there, this was pre physically based rendering and pre path tracing. And before those times, the way they would achieve beautiful pictures was basically like people doing lighting. They were almost painting the frame. I think what they were doing is closer to painting than s- doing lighting for a stage. Or in architecture or in a theater setup, you put lights and you design your lighting space. But what Pixar people were doing were really almost thinking in 2D, like putting a blob of color here, and this shadow has to be purple even though the light is yellow, so that it's more dramatic. And sometimes the light direction and the shadow direction wouldn't match on purpose. They had controls for each one of those things. Like the lighting needs to come like this, so the rim in the character is beautiful. But now the shadow is coming too close to the camera, it's distracting. Let's move the shadow that way. So you have two light directions, one for illumination, one for shadows. All those tricks. And the ambient occlusion would be colored arbitrarily. And I still use this trick today in many things where you don't want your ambient occlusion to just be grayscale, a floating point value, a scalar. You want to be colorized so that the concavity of objects uh, have more saturation, because normally, if there is light coming to a little corner like that, if this object is brown, it's a rock, but there's a concavity, then light comes in, and the bounce light that is going to hit the top part is going to be white from the sun times brown equals brown. And the second bounce is going to be white times brown, so brown squared, which is a very saturated brown. So you need the ambient occlusion, all this darkening, to be highly saturated. So the ambient occlusion was colorized, and it was artistically driven. Like, I, as an artist, as a painter, want this occlusion to be this way. And so all those ideas of cheating, not only cheating photorealism, but achieving an artistic goal through very fine control of lighting and non-physicality was super important back at Pixar, and it became important in VR for these movies we were making as well, because we didn't have the budget, like the milliseconds. We had to render in 11 milliseconds, which is 1,000 over 90 frames per second. So we had to render 90 FPS twice. We had 11 milliseconds for everything, not only for rendering. So the lighting was faked in that I placed volumes and developed analytic equations that would let you compute how much color contribution should be given in a point, should be in a point given the center of the 3D brush that you were using to colorize that area of the space was located somewhere with a given fall off. So there's these quotients that you have to integrate. And it was super fun. So I developed all those tools to very artistically design the space and animate everything. So as there's a transition from day to light, or at some point the character became sad. So we desaturated all the colors. We changed the rig. So all the things had to be dynamic. So it was fun to do the math with an artistic goal and implement that in Unreal Engine.
Why did you use Unreal Engine then if you ripped out most of the rendering, lighting?
Or the asset pipeline
Okay.
to get the artists to create their animations in Maya, bring them as FBX, get the updates by just drag and dropping the FBX to the right folder for textures, and
Okay.
for sequencing, to sequence the whole
Oh,
piece. And some of the elements, it wasn't an interactive movie. Like the arc of the story was fixed, but there were a couple of events that would happen sooner or later, depending on whether you were looking at the right spot as a viewer in 3D space or not. So there were a few blueprints and a few scripts that were deciding, uh, they were triggering some of the little uh, timelines, and yeah. So other than for rendering, we used everything else extensively in Unreal.
okay. How did you then go around these issues that you mentioned in the beginning about like where viewer is looking during the movie? Like,
Well, to some degree of success, not completely. We use lighting, we use sound cues, um, and also a lot of it was placing the viewer in a place, in a location inside the stage or the world, where there wouldn't be many interesting things to look at anyways in the areas we didn't want people to look at. It was a combination of things. I'm not convinced we succeeded. I think we did a good job. We did our best. The story is a fun one to watch, but I'm sure that it's been now 10 years of VR. So people who are in the space probably they have developed way better techniques and they have their own how-tos and recommendations. But at the time, it was all new, so we did what we could.
Mhm.
And the second project there, maybe to well, go ahead if you have.
I was just wanted to ask, could the viewer move around the scene?
Yes,
Okay. So
yeah,
all
to
of
some
this,
degree. Although the
all of this.
recommendation when we gave demos, we went to Tribeca and a few film festivals around the world to show it. I think South by Southwest had a section for VR films at the time, or maybe that was the year after. But I know we demoed the thing in many places, and we would bring our own carpet, a little square carpet from IKEA, a round carpet about I don't know, like 2 meters wide, and a pillow, and we would ask people to sit in there because that's also what in the VR world, in the virtual world, where you were sitting looking at
Okay.
the things, but you had that kind of tactile
Okay.
version of what you were seeing. But that also prevented people from standing up and looking around too
Okay.
much. And then soon after, so that was the first version of VR, the DK2 and the Oculus Rift. The first um, VR headsets were mostly about sitting down at your desk. It was the later versions that encouraged people to do room scale VR, as they called it, where you put your sensors around and you can walk and you have the touch controllers and you have your Beat Sabers and all those things. But the first generation was very desktop centric, like you are
Okay.
sitting in your desktop. So we benefited from that as well.
Okay.
But yeah, you could definitely stand up, walk, and start crossing polygons and click through everything.
Okay. But then you had this framing, at least. Like somebody could look around, but they couldn't just go behind the characters. I mean, they could, but they were not likely to.
They would have to physically stand up and walk
Yeah.
and walk behind the character and look at his back. And you could do that. Yeah, yeah.
Mm.
You could even put your head. It was very fun to put your head through the body of the character, and you could see the internal geometry.
Okay.
Actually, I think there is a hidden gem there. I think we added a heart inside the character. Totally waste of polygons. But if you are brave enough to stick your head through the character, you can see a little red heart inside of the character.
Okay. By the way, on the heart subject, you have
Yes.
tremendously good heart video where you are sitting on your YouTube channel. I invite everyone who is listening to watch your video with the heart. You're sitting in front of the desk and you have beautifully rendered heart. And then you also apply all the lighting and you can see that like you spend a lot of
Yes.
work to get the
Yeah, it
reflections in
was.
the heart, like to make it so it's so real life. Just near you.
Yeah, that was my first attempt at doing VFX work, like imposing synthetic data on real footage,
Yeah.
background footage. So yeah, it's a tutorial where I explain how to build, how to shape a heart out of a sphere with mathematics. You start with the equation of the sphere, x squared plus y squared plus c squared equals radius square or something, and then you start adding. I'm going to divide c by x, and then I get a deformation like that, and then I'm going to put an absolute value so both sides deform equally, and so on. So I give a live demonstration where while the thing, the sphere that eventually becomes the heart, is there in front of me on my desk.
Yeah.
And I made that in Shadertoy, actually. It's
Oh.
the whole video, other than my face, obviously, it's a
Oh.
big shader written in Shadertoy that I synchronize to my words, and then I uh, basically put on top of the real footage. But I did use, as you are saying, I did put some effort into matching the lighting. So I know in my video I had a window in front of me,
Yeah.
which is screen right. So I put a fake dot product in my shader for the heart coming from the right side to create a highlight there, and I try to match the colors. And I also had to add a bit of uh, random grain to the shader, like noise, a bit of dithering at the end of the shader to match the grain of the background plate. Because my camera at the time was 2016. I didn't have a good camera, so I just recorded with my phone, I think, and I had to match the same artifacts that the phone had. It's there in YouTube, yes.
Yeah. Uh, so let's. I would like to talk about Shadertoy, but let's finish the Oculus
Yes,
part.
so yeah, because you were asking about tools. So after this film, where still we hard coded the lighting and all that in the shaders in Unreal, finally the next movie we made was called Dear Angelica. And the goal there, the director was Sashka from another Pixar friend, and he wanted to recreate in VR what would it be to be in the memories of a 12 years old girl or something who misses her mom because her mom is an actress, she's never home, she feels the some emptiness inside, and she's all she knows about her mom is the pictures she sees of her in the movies. So when she thinks of her mom, all she thinks is about all these superheroes and characters. She doesn't know her mom really is. So we wanted to recreate all those memories of this girl, of her mom as a character in all these movies, but because it was a dream, we didn't want to do anything photoreal. Plus, we couldn't in real time. So we went for a very cartoony, illustrative style. So first, we tried to create that look. I was the look development guy, so I tried to achieve that kind of painterly or hand-drawn illustrative look by, well, putting billboards in 2.5D with a bit of parallax to get them some depth, positioning in 3D space, some tricks, filters, whatnot. It didn't really look good. It looked very synthetic, very, very good, not good. So I decided, inspired by Tilt Brush, which was a drawing application made by some friends who later got acquired by Google. But I gave it a try to the tool. It wasn't good enough for what we needed. It was meant for a different type of work. And so what we did is to hire. I asked, can we have? Let's stop all of this. It was a bit like this. At Pixar, I had like 3 months failure, and then I had the fear they would fire me. But then I saved myself by doing something better. In this case, it was again a failure, but this time I was in command. I had matured a bit, I guess, and I was like, okay, this is not working. Let's stop everything. We don't need to fire the people we got, but let's start from start. Let's hire an illustrator, an artist.
Okay.
She or he doesn't need to know anything about computers, Maya, Blender. Just she needs to know how to draw, and we will make the tool for her. And I made a tool where she could draw in 3D space with all the benefits of a digital tool and do, redo, copy, paste, all that, but without uh, but with the hand touch and tactile touch of a real tool, where the strokes that she laid in space, according to her flow, about her ideas, about the style she wanted to bring, we respected it 1,000,000%. It's not like, in traditional filmmaking or probably in game making as well, you have the vision, the artistic vision, which is made in sketches and drawings and watercolor, whatnot. And then that gets interpreted through technical artists who make it into models, textures, and whatnot. And a lot is lost in between. At Pixar, the drawings that you can still see if you go to an exhibition look beautiful. The movies look beautiful, but they are something else. They are different. It's not that. So here, all that was gone because all the strokes that she was laying in space, we respected. And that meant a lot of control points. So our technical challenges became not shading and texture bandwidth, but it became geometry bandwidth and how much we can rasterize. But all those strokes that she was laying, all the virtual paint, were all polygon strips in 3D space, and it was super successful because the work was beautiful, was fully volumetric, and she embraced the medium very quickly. And connecting it later with the sign distance fields and all that, and what I'm doing now in Adobe, that was the first time I realized that technology and GPUs, the ever-growing GPU power, shouldn't necessarily be used to create better shading and better skin shaders and hair shaders for our characters and more photoreal hair. And we shouldn't always use it to get more characters in the screen and a bigger world and more plants and flowers. That's the easy way. That's the non Okay, that's the wrong word. It's not easy, but it's less risky, let's say. Just trying to do, okay, the goal is Planet of the Apes in real time or Transformers in real time. Okay, well, that's difficult to get there, but as a creative goal, it's an easy one. You just pick something that exists and you're going to try to do it in real time, which, yes, will open another creative set of opportunities for real time storytelling and interactive, blah. But in terms of um, as a vision, it's not super, super creative, I think. But I think it's more interesting to think how we can use the GPUs not to make more photorealism and bigger things, but to make the UX of easier and the UX user experience, the creator's experience easier. how to use GPUs to enable more artists to do work and be creative and create 3D content. Because if you think about it, how many 3D artists are in the world? 100,000. How many 2D artists who do illustration, Photoshop, billboards, T-shirts, art, pamphlets? How many of them there are? 50 million. So we are talking of two orders of magnitude. So why these 100x people never touch Maya or Blender and contribute to making films and games? One of the reasons might be is because those tools are and pipelines are super, super complicated. And that's because we are asking them to know about subsurface samples per pixel. They have to know edge loops, polygons, UV maps, rigging. So if we can use GPU to change the creation paradigm, so all those technical barriers are gone, then we are getting somewhere. And I was always thinking like, programming. We went from programming in assembler to programming in high level languages like C++. Although maybe web developers don't think of C++ as high level. But the point was that there was a time where we went from having the programmer busy thinking of instruction parallelism, and I have my U pipe in the Pentium chip and the V pipe, and I'm gonna interleave all these things. Oh, and the memory cache, I'm gonna align my data this way. I'm gonna put the dummy thing here so the 64 line cache alignment thing works. All that was gone at some point, and by using a higher level language, we could focus on the algorithms, on the problem at hand, at finding a solution and designing a solution for the problem, not on low level details, although those things are still important. So I think modeling has to go through the same revolution where, the artists are there, the poor people are there, like connecting polygons and making sure everything is quads, not triangles. Oh, and polygon budget. Oh, I'm going to subdivide it, but not too much. I need to have an edge loop here to capture this detail. They should be thinking not on those low-level technical things. They should be thinking of the higher-level design goals. What's my character? What does he look like or she look like? How many characters can I iterate in a week if I don't have to worry about all those things? So Quill, the painting tool that I developed for that film, was the first time that I saw that by using technology, not for better shading, but for enabling a new workflow, enabled this artist who had never done 3D in her life. She was a classically trained artist. Suddenly she was making 3D content for a very high-tech thing, like a VR film. So that realization is what has been driven me since then, like using tech and GPUs and power to change how content is being made, not to make more content. Because also, if you think of, I don't know if the metaverse will ever make it, but um, it looks to me like the future is gonna it's gonna require a lot of 3D content. Hopefully, we'll see. But if that's true, if the metaverse is coming or we have anything like that, and there is a need for 3D content, we don't have enough 3D artists. And sure, generative AI might fill the gap to some degree, but still, I think people will want to put 3D stickers in their TikToks and whatnot. So anything we can do to democratize content creation through the use of technology is good. And I'm okay doing simpler visuals. I'm not so interested anymore, like I was at Pixar, of creating the most photoreal and complicated thing in real time. Now I'm focusing more in how can we use GPUs to enable artists.
Okay. Can you walk me more in detail how Quill how Quill works? So you mentioned polygon strips, but
Right.
in 3D you have 3 dimensions, so I'm doing a loop and then this loop doesn't necessarily match. So like how does this happen underneath?
Yeah. So the code, so the rendering technique is relatively simple. I think I was using tessellation shaders, but basically, as the artist lays a list of control points in space, I think actually they weren't even control points as you would think of them in a Bezier or a spline setup. It was really just a set of points in space that we were sampling at 90 times per second. So every frame at 90 times per second, we would ask to the hardware, where is this hand in 3D space in XYZ coordinates, and what's the velocity? So we could estimate acceleration. And all those points became a vertex buffer, basically. And then in a tessellation shader, which were popular at the time, uh, we were extruding that. I think it was a GL line adjacency primitive or something, or line strip. I don't remember, but we would expand all those into polygon strips, sometimes as a flat ribbon, sometimes as a tube, and The topology was pretty messy. We didn't solve the usual thing where you have a very high curvature area and now the strip, the tube is intersecting itself and so on. We didn't care because we were not shading. So we were not applying lighting to any of this geometry. We were not doing any n.l computation. So everything was flat um, lit because the metaphor here is that the artist is not sculpting surfaces. The artist is laying ink. And basically,
Mm,
everything that looks like a volume in the movies or in the art, people still use it today. Quill, it's been used for I think some Netflix shows are using it, and there's also lot of small studios using it and still publishing VR content. Um, so the content you see there is being painted. If you see a shadow on the floor, it's because the artist went and painted a shadow. They picked the a dark color and started painting strokes, laying strokes down. It's pretty much like you give someone Photoshop, and the only tools they have is the brush, but not without textures or anything, just the flat Gaussian blur, Gaussian shaped splat, and the color picker and the eraser, and there they go. They start painting, and anything that has to do with lighting, shaping, it's coming from their hand by painting it, which is beautiful because again it's not technical, but it played in our advantage the fact that we could have a messy poly soup with self-intersecting polygons with whatnot, and still be look okay because everything is flat shaded
okay.
and everything blends together. But there were some technical challenges, like I had to implement transparency. So there I used the dither alpha mask, alpha coverage thing that I was talking about earlier, but it came with some challenges when you have multiple layers, but still worked kind of okay. And the challenge was always how many polygons can we push per second? How many million of polygons can we render? We were doing obviously some of the basic things like frustum cooling, but we couldn't do occlusion queries really because the data was very sparse in space. Like there's a stroke here and another one there, but maybe there's a little gap in between, and we want to respect what you see through that gap. We don't want to fill it and assume that it's opaque. So it was a fun uh, challenge. And then we did tricks to, at the time, it's just when the some of the OpenGL extensions came out that allowed us to do one geometry pass only and split into two different viewports with two different view matrices. I think at some point, actually, no, I was using instancing, so I would render everything in a big GL draw elements in direct instanced, one of those huge GL API
Okay.
commands that allows for instancing, and then I would project through different projection matrices based on the instance ID to the left and to the right viewports to have stereo rendering twice, but only with one render call.
Okay.
And
Wow.
the
Uh,
whole thing was again just the regular C++ and well, not regular. I guess it's the C+. I don't know if you would go to that rabbit hole, but
what do you
the
mean?
whole everything I do is always like just the old school C style kind of programming.
Ah, okay,
Um,
okay.
I
That
think you got covered.
I think on this podcast there are so many people that code in C plus.
But yeah. I don't
And
know. I think it goes by different names. You can call it C plus. Some people is orthodox C, but C plus plus. I call it sane programming. Just being sane. Don't do the crazy thing, guys.
okay,
Don't
so
do spaghetti pointers everywhere reference craziness. Just
are you fan
be
of
tidy.
modern C plus plus with the newer abstractions, newer STD things, or not really?
No, I mean, I use some things. I guess like everyone, probably you can handpick a few good ideas from modern C++. I like lambdas. I like some sort of all the const expression things to evaluate things at compile time. It's great. Uh, enum classes, so you have enums that have strongly typed. That's great. But actually, I don't even know if it's C++ per se as a language. What I don't like, it's all the philosophy of complexifying your life and not having clear and clean object ownership policies. Like, why have I don't do any of the resource allocation is what is it? Resource allocation is
I
initialization, whatever. The
Initialization.
RAI.
Yeah.
I don't do smart. I think if you do smart pointers, you don't you don't understand your program. I think if you need to hand over ownership and destruction and creation to the system is that you're not understanding the flow of data in your application. And I think we should ban it. You know how in the old days we banned goto? Goto proved to be a bad idea.
Yeah.
I think smart pointers is the new goto. I think.
So you're against the current. You're not a
Yeah, it
fan
gets
of
in the way, and
Rust
I'm not
then.
even concerned about, all the objects are not next to each other in cache, and they are not, it's going to be L1 cache misses, and it's not even that. It's just, as a programmer who is looking at the source code, I want to understand the sequence of steps when things are allocated. Who owns what is the hierarchy of ownership, who initializes what and in which order, and when are things created and destroyed. And the moment you have flying objects in the ether in memory being pointed by very delicate strings, which are the pointers, which are trafficked around, it's not I cannot follow what's happening in the program. So it's easier, it's more difficult to debug, to understand, to optimize. And the same with the modules. Like if you have, I don't like the whole idea of having a constellation of singletons all around. I don't like the object oriented paradigm, basically, where you have objects floating around and they send messages to each other, like if it was an Elixir service or something. That's maybe fine for web, but in an application, at least the kind of applications I write, I don't want to have this kind of hidden connectivity layer that I don't see, because everyone is storing and caching a reference or a pointer to another singleton that is doing something for them. Because then I look at the code and I cannot track who knows who is depending on who, and what is happening. It's like maybe it's because I'm an electrical engineer. I always think about that, because in digital electronics, you have your chips with input and outputs, and you see the wire that goes from one to the other. It's not like you have chips in the PCB in the board, and they send messages to each other through an invisible bus that with listeners and observers. It's none of that. You see the actual wire going here and there. So I like that of my modules. Maybe it's a professional uh, problem I have there, handicap. But I want to see, if the renderer, if the scene is pushing something to the renderer and the camera is being used, I want to see, in my scene, I want to see objects rendered and then passing the renderer, passing the camera. I want to see the parameters, the wires going into the module, into the input
Yeah.
of the next module, which is the function call, the API. I don't want this to be clean and easy to read because it has no parameters. But then somehow I have to guess where this other module is pulling that information, which
Yeah.
might be coming from a singleton pointer or from a megabus. And dude, I want to see the flow of data, right? I want to see the wires. So anyway,
Yeah.
that's how all this the Quill thing was programmed, which became a challenge because, to be honest, and in fairness, I understand why people used to do the old school C++ things with hierarchies and inheritance and the factories and all these design patterns, which I think people are realizing are wrong. But they did serve a purpose, and it is true that this was my first project that was not a toy project, meaning all the demoscene work I had done, small by definition, a small project that fits in a 2 months bucket. There's no repercussions, no users will complain. Easy. I can do whatever I want. Then the first job, that was the VR engine with the silicon graphics stuff. Flavian took care of the bigger architectural work, and that's where I actually did all these design patterns. So I know all that stuff. It's not like I hate it just because I've been there. And then Pixar, again, no customers. So as long as the shot renders, and my cosines and sines and my shared memory
That's
system
true.
produce the shot, it's done. The frame is now in the disk. This thing can crash for all I know. So it wasn't really a very serious programming. I didn't have all the responsibility of a real application. But now this was the first time that I was making something for users to use who would complain if something was crashing or wasn't fast enough or whatever. So, and we were like 3 people in the team, 3 engineers. So still small by comparison to any other team like we have now in Adobe. But it was my first time that I had to prove that not doing it the old school way, the traditional C++ way of doing things, could work for a bigger thing. And it did work. It wasn't perfect. We did some mistakes here and there, but at least it proved to me that my intuition wasn't completely wrong. Like, yes, you can do things in the same C++ way.
Okay. Okay. All right. So this was Quill. You work at
Yeah.
Facebook. I am assuming after Facebook acquired Oculus. Or
Yes, yes,
okay,
yes. Actually, yeah, exactly.
okay. So you
Um,
remained on the same project per se.
yep, I became the in when I was in Oculus, I made the tool for the movie. That was the goal. But then we realized the tool had potential because we were sharing the tool with friends from Pixar and other places, and they liked it. So we got a signal that this is people like it. So it was a small, as kind of a spin-off thing where I took the project and we built a team around it, and I led the project within Facebook, or what now it's Meta, but it was Facebook at the time. So I became a bit the product manager, meaning the person setting the vision for it, the goals, the roadmaps, hiring, and doing the engineering, the higher level engineering decisions. So yeah, that became my first, well, second time I guess that was doing more of managing people and a product, which I did enjoy the part of deciding what the product is, who it is for, what to do, what not to do, how to market it, how to go to the studios and talk about it, how to listen to them, what needs they have so we can sell it. Because my strategy there was, well, VR, the world is not ready for VR. You know, by the time I left, it was 2019. From the 2014 that I joined Oculus, had been 5 years, and the industry and the VCs, the venture capitalists, like with every other thing, they went from being super hyped to realize that it wouldn't really take off. Um, you might see similar things happening now with other in other areas. And by the time everyone realized that VR wouldn't be that everyone wouldn't have a VR headset in their living room and be watching Netflix in it, that it would become something a bit more niche. Still very useful. Doctors can train how to do surgery in it. If you are in gaming, you can game and so on. But basically, that the whole thing would be much slower than anticipated. My strategy there was to start using Quill not for producing VR films, but to help traditional filmmakers like Pixar and Blue Sky and DreamWorks produce the films quicker, because something we noticed, and it was subjectively measured through many studios, is that people who were using it could sketch their storyboards or their character design ideas or do the initial pitch for a set for a movie to the designers and to the director much quicker if they were in Quill, because again, all the technicalities were gone. You didn't need to do, gray box in Maya and set up some proxies to kind of sell the 3D world and the scale of things. You could just draw it, beep, 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 you draw it. And people who had never traditionally been able to do 3D in Maya were now doing 3D content to show to the director. So we thought, well, we can try to plug Quill into that pipeline to save a lot of time to the production companies. And over the next 5 to 10 years, while we wait for VR to take off, still hoping that my hope at the time was that Apple would release some sort of VR headset, and being Apple, they would drag the world with them. So it was 2019, 2018. I had a hope, but I had to wait. So the waiting time was starting to use it inside studios and train all those artists to use Quill and be VR native themselves and develop their art in VR. So by the time headset would be everywhere and there would be a market for it, for VR content, they would be ready to convince their studios to make a short film in VR, perhaps. My dream was always like the year 2030. I think it was 2025. Now, I was so naive. I thought 2025, my dream, I think the pitch was 2025. I want to see my daughter uh, be with Olaf, the snowman in the Frozen movies, being with him in the forest, jumping and walking around in VR space. There's the story, and then there is this interactive moment in the film made by Disney, where, and actually it was fun because we got uh, Keenan, what's his name? Oh boy, I forgot. Super famous. I'm gonna kill myself for not knowing this, but this super famous 2D animator who animated Tarzan and and
Okay.
Ariel in the Little Mermaid, all these things. And he tried Quill, and he loved it because he was back to traditional drawing. When he was at Disney, helping and co-directing Tangled and helping them create very cartoony poses and less CG looks for the things. He was doing all these drawings and so on. but he would never you never saw his hand directly in the big screen. But here he took Quill and he was able to create beautiful animations like old school. And it was the animation system was based on flipping the page like old school. Basically, you could copy the content frame to frame, but then you would draw over the previous frame with onion skinning. And we have some tools to do twinning between point A and point B and so on. But basically, the main paradigm was frame to frame drawing, only supercharged by Control C, Control V, and all these things. And he loved it. So my hope was that eventually Disney would come back to 2D filmmaking or hand animation, but in VR.
Yeah.
um, but yeah, I'm still waiting for Apple to release a headset that works.
Yeah, Apple did
I like so
release.
many friends today.
Apple did
I have many
release a
friends in
headset.
Apple, by the way. Sorry.
Apple did release a headset, so you know, but the future is that everybody is not in VR, so it didn't happen yet.
It didn't
Uh,
happen yet. We'll see. It's probably like ray tracing. It's always in the future. It's the future.
exactly. You are a hardcore engineer, and then you are in the position of being like product manager, with like
Right.
detached from this low-level engineering. What did you like in this position, and what did you hate?
Um, so the idea of designing a product and building the story around it and the vision and all that, I love it. Like, and this was my second time because I also built Shadertoy with Paul Jeremiah's, my friend, another Spaniard living here in San Francisco. And even though that was a toy project, we have a few, like 100,000 users plus, but it's not like we make money of it. There is no really pressure to make it grow or anything. But that's where we exercised our first, you know, product management skills. Like we had to decide, what is Shadertoy? Who is it for? What's the messaging here? Are we adding a lot of tools or not? Are we allowing people to upload meshes and their own textures, or do we keep it contained, constrained with the repercussions that has? So we had to do a lot of decisions there, and eventually we decided, let's keep it, um, you know, simple UIs, simple to use, not complicated. Uncomplicated. The complexity is in people's skills, not in the to make math and graphics, not in the using the tool. Anyway, right or wrong, we had to do lot of decisions there, and that was the first training. And then Quill was my second time kind of deciding, and I love it. It's very thrilling to have an idea and then thinking how you are going to sell it to the world, what is the niche it fills, how to get there, and what not to do, especially because the moment something starts becoming successful. And so except for Shadertoy and maybe another project that we did, Paul and I had another little startup that we built some technology and then we sold it right away. Uh, but everything else I have done as a product manager, it's including now in Neo, perhaps, it's always in the context of a big company. And the moment your idea starts being successful and having traction and users come into it, there is people chiming in who has an interest in getting getting a piece of the cake. So very quickly, there's a lot of people in the kitchen, many cooks in the kitchen, is it in English, and a lot of opinions and different interests, and also most of them, everyone, I would say, with good heart. They want the best, but they have a different idea of what's best for that product and for the market. And then you also might have people who don't like it so much. We were working in a previous project what was a bit similar, and now they feel threatened, and the immune system of the company comes to attack your project because you're a new thing, even though you're good for them. And then takes politics. So there's all this soap opera happening around product management, which I like.
You
It's
like it?
distracting, and hopefully now I have someone who is much better than I am. Dave Cardwell. He was at Weta. He created Madbox. He's a genius, and he's taking care of a lot of that. But I'm enjoying being very close to all of that. And in Quill at Facebook, I was definitely the one getting all that hit, and it was fun. But eventually, um, I left the company because, well, for one reason. First, the VR thing wasn't really taking off, and I found myself with less and less time to do pretty shaders and C++ coding. I was road mapping, and especially in a company like Facebook, um, they change leadership very quick, not at the top level, but middle levels. Leadership changes very quickly, which is good. If someone doesn't bring results, they replace them with someone else, which I like. It's a very ruthless natural selection kind of thing. But that means uh, people right above me were continuously being replaced, which means that every time I had to pitch again, like to an
Yeah.
investor, like why they should invest in my team. The new people coming, the new leader, and I had to be, oh, this is the dream, and Pixar, and Olaf, and my kid is gonna be with Olaf, and the amazing artist, and meanwhile, Blue Sky and DreamWorks will use our tool while we wait for Apple, the whole thing, and justifying everyone who was in the team why they were there, what they were doing. So that part, um, I didn't like that much because it's not so much about thinking of the product. It's much like day-to-day logistics and defending the team and defending the project, which I guess is what a CEO has to do when they get money from an investor, which I would never do because of that. So that's the ultimate reason I didn't continue forever. But the product management itself, the vision, all that, I love.
Okay.
Yeah. But that being said, Facebook was amazing. I know it has, at the time, it had very bad press because of uh, things, the world, but I think everyone was there pretty, what's the word? They knew what they were doing. They were high quality people.
Okay.
So I enjoyed it a lot.
Okay. Okay. Uh, I realized that we skipped over Shadertoy, and this is like extremely
Go for it.
successful project, well known in the industry, and for a lot of people, this is like a go-to place to even learn shaders and then start there. So tell
Including
me,
LLMs. That's where they go to learn shaders, all these AI
oh,
scraping tools.
didn't
Yeah. Let's put
realize
that in the
that.
side. Go on. Sorry.
So let's paint the picture of what the Shadertoy is and how it was created.
Yeah. So Shadertoy is a hmm, it's a community based project. It's okay. Maybe I can say it like it's the YouTube for the computer graphic nerds, like myself. I said nerds with love. I don't say it in a bad way. So I don't know if geeks is the word. I don't know very well all this lexicon, but basically you go there to learn from people who are publishing shaders in there. So imagine YouTube where there is a list of videos, but in this case, it's a list of shaders. You can click on them, watch them. They are rendered live in your viewport in the browser. There is a comments section below it for people to comment, ask questions, congratulate you, whatever it is. And then on the right side, next to the live shader being executed with beautiful graphics, you have the code that is responsible for making those visuals. So that code is live. You can change it live and see how that affects in the visuals, how the things were constructed. So you can very easily start going through the code, which normally even the most complex shaders is one block of maybe, I don't know, 500 lines, not super crazy. It's all contained in there. It doesn't use external libraries or frameworks or infrastructure. Everything you need to know or to do to see those visuals is happening in those lines of code. And it's very easy for you to go in there, comment out blocks, change names of variables, values, and see how and explore and deconstruct how the shader on the left side was made. So it's a great learning tool. It's a great prototyping tool that I use it every day to prototype things and ideas because I don't need to open an engine or a framework or anything. I just jump in there. It's like Google Docs. I can go in and start typing. And it's also a way to brag about your skills perhaps and build a little portfolio or a little thing that you can show around. Actually, there's always these two visions for it, and you could think of most people I think see Shadertoy as a repository of good ideas of shading techniques. Actually, many of the papers that you read at SIGGRAPH or GDC things they have a Shadertoy sometimes, and you can see live demonstration of what the paper is teaching. I know teachers use it to teach at schools and the computer graphics schools and so on, computer science. Um, but in that way, you can see it a bit as a repository of knowledge and techniques. But I see it more as a gallery for artists and technicians who have a bit of an artistic side to them, to their work, to show and to publish what they do. And that's how I'm one of the um, I'm not the most active contributor. Like we have a few people who are like super devoted to this. Although generally we have a very healthy community. I think we have 120,000 users after cleaning all the bots and all the spam. So it's quite big, and every day there's like 20, 30 new shaders, which is pretty good. So it's a very healthy community. But of course, it's a J curve. You have some super users who are all in, and I'm one of them. So about half of my shaders are technical, like I'm showing a technique, like this is how you optimize this, or this is how you solve an intersection between array and this particular crazy shape, and this is whatever. And then the other half are more pieces of art that I work like a bit more like the things I would do at Pixar, where I create a beautiful landscape or a human character all made of equations and shapes and all GLSL code, basically. Again, without using meshes or textures. So you really have to shape volumes, stamp, color, project lighting, inject animation, and all those things through code. Uh, and there is many people who are also in the same boat as I am, and they are creating beautiful artwork as well in there. So it's a combination. It's a web tool, community, repository, art gallery, educational tool, all those things together with a UI that looks straight, that came straight from the 90s. Very, very ugly UI. And
But it
we
works
know it.
fast
It works.
and it
It works
helps.
for now.
And it helps if you have this, for example, the shader you mentioned, the realistic character, the cartoony character you've made, and like at least at my page froze because it took so much memory and it needed to like do the frames separately. But the shader was like incredible, the character one.
Mhm.
So
Well,
how did
that's yeah, go ahead.
how did you have this idea to build such a thing and then like have this as a publicly open free thing?
Yeah. So actually, the first version of Shadertoy is from 2009, um, which I was looking up the other day for another reason, but I realized that CodePen and some of these other similar tools where you can publish code and see live what the code is doing. We predate all of that, which is funny. So this was in 2009, but at the time, that was when WebGL came out for the first time, and I was all excited about it. So I made a version of Shadertoy which had the shader on the left, the visuals, and it had the code on the right side, and you can edit the code. But there was no community for it. I didn't know how to do any PHP. So Shadertoy is all old school PHP in a
Nice.
LAMP server somewhere. So I didn't know any of those things. So I was getting shaders from people who would email me their shader. So being in the demo
Oh,
scene
okay.
and being with all these, having all these friends who were doing 4 kilobyte demos and intros, as we call them, I would message them, hey, can you send me the shader that you use for this, for your demo for the Breakpoint 2008 competition? And they would send me the mail with the code, and I would put it there. So we had like 50 shaders or so running, but you could still explore the shader, deconstruct it, and try it, and so on. But then in 2013, um, uh, I do not remember exactly what was the trigger for it. Maybe it was CodePen, although I don't know if CodePen still existed, but for some reason it was clear we had to do the community aspect of it. So I sat down with Paul Jeremias, who at the time was working in LucasArts, I think. He later went to work at Pixar. Finally, just when I left, but we went to LA. We were there for some conference. I think I don't know if it was a SIGGRAPH or something, but we decided to stay 3 or 4 more days there. We booked a hotel. Uh, it was a nice hotel with a rooftop. Basically, we spent 4 days in the rooftop, like nerds, not going in the pool, but with a laptop next to seeing everyone else in the pool. And we coded the whole thing, the Shadertoy thing. It
Nice.
was basically PHP, basic CSS, and JavaScript. No complexities. Everyone we asked for advice. So I was complaining about the C++ community. I have similar
Let's
feelings about. I'm gonna make so many friends today. I had the same feelings about much of the web development world, because all the advice we got was, oh, you have to install all this infrastructure, all these frameworks, npm, the manager here, the ninja there, the yarn here, the node here, the whatever. It's like, what are you talking about? Can we have an SQL, SQL? I don't know how you pronounce it. I think SQL database with some tables. Yeah, but you don't do it that way anymore, because why not? Oh, because. So we went with our instinct. We didn't have time basically to learn all those extra things, and it wasn't an investment. We wouldn't have any return on that investment, because like we are web developers. Paul writes shaders in film and game studios. I do the same. So there was no point for us to learn all those things. So we just went with a path of least resistance, and that was PHP, an SQL database, and some JavaScript and CSS. So because of that, we built it pretty rapidly, and we've been maintaining it and adding features since then, relatively slowly, but it's been fun. Um, yeah,
How much
a
time?
bit.
How much time? How much time do you spend on maintaining it?
Well, these days, not that much. So for the most part, Paul and I would meet. For the most part, I mean, from probably 2013 to until 2020, we met every Tuesday at night after our respective works, and meet after dinner. Kids are in bed, and we whatever we have there, 2 3 hours, we would go and code the next feature. And um, it's always been a hobby project, in that there's no ambitions for growth or anything. We don't make money with it. We have a Patreon account that people donate to, and basically we use all the funds um, to to pay for the servers, the AWS servers, the SSL certificates, and the domain names and all that. So yeah, there is low pressure, which is great. But and now these days we do less of that, but there is a lot of work in the community. Like every day, I have to remove a few spam shaders. The last battle we had to, yeah, this it's incredible. People submit
Oh,
shaders, and all it's just for spamming about a company or about a service. Or we have
oh, okay.
everything from the darkest thing you can imagine to someone announcing, "I'm renting a bus." And okay, so all those things have to be taken down to keep the community clean and all that. But it's not very. It doesn't require much effort, because I'm a user of the tool every day, anyways. I
Okay.
love going in there to after work, going to Shadertoy, and going to a little hyper focused rabbit hole about solving some useless problem that no one cares about, but I'm there solving my equations and optimizing and the whole thing. So because I'm there anyways, I see all that noise coming in from spammers and whatnot. So I kill all of that, and then if I see a pattern that repeats, then I try to automatize that, blocking that thing. But it
Okay.
doesn't require much maintenance, and the community, I must say, it's a very good community. We only have, like, in 10 years, well, 12 years now, like maybe one or two instances of a conflict or some bad energy thing happening that required going offline and send emails to each other to kind of figure out what's happening. We had like two of those only, and we have, again, hundreds of thousands of registered users, millions of views every day, and it's every week, and it's people are great. I'm very
Okay.
happy how the community turned out.
Okay. Is it self-sufficient financially? The Patreon thing, is it enough to cover everything?
Yes. The first few years, we had to put money from our pockets every year. Now it's basically, I mean, I don't know if Paul would allow me to share numbers, but I can tell you we are doing like 3-digit numbers every
Okay.
year.
Yeah. Okay.
Maybe 4 digits, maybe 1,000 if we get lucky, which we might use to print T-shirts someday or something. So yeah,
Okay. Okay.
at
Oh,
this point, even if it wasn't really, I think we would still maintain it and put the money. It's fine.
yeah.
Um, yeah.
All right. Uh, do we have anything on Shadertoy, or do we move towards Adobe?
Um, no, I think Shadertoy. No, I think that's a good overview. Yeah, let's move on.
Okay, okay. One thing on
Mm.
Shadertoy, I love. There is a. I will link this in the description. There is a skull that is also made like by definition with all the math equations that is like
Yep,
forming in to this sort of like a wall, forming in and out of the wall,
right.
just going like in a loop. It looks
Yep,
so cool. It was
yep.
so awesome. I love
Yeah,
that.
I'm telling you, these true artists in there, not just great programmers, but the unicorn, the people who can do beautiful art and and code it. So and there are a lot of those. It's super cool. And I mean, another reason I go there every day is to learn. It sounds a bit corny, but you do learn by going there because especially in my case, I go there almost every day. It's to me going and write a shader or improve a shader or something. It's almost like a routine. Like I wish I had the same strength to go to the gym or something. But there's this thing I do every day, and because some of the days at work, all I do is thinking. I don't really do much coding, although I'm in the process of changing that again. But sometimes it's just like my little space to be happy again to go at night at 1
Okay.
a.m. when everything is silent and I can code. And so it's also a bit like to keep the skills up. I sometimes say that it's like pianists that play scales every day, even though they can't play Mozart. Every day they do their ta-ra-ra-ra-ra-ra-ra-ra to keep their fingers, and so it's the same, right? You go there every day, go every day, you do some shaders to keep my uh, stay up to date, and I I think I have seen. I'm not going to say every shader that exists in Shadertoy, but a huge fraction of them I have looked at them, like look at the code, and of course people do things differently than I do. I have my patterns. I've had all this practice every day. I have built my little conventions, my little ways of doing things, and people have different conventions and they find solutions, different solutions. Like just recently, actually, it was a great example where there was this thread in and Twitter about using arctangent and how expensive that is in terms of how many instructions it expands into in the CPU because there is no intrinsic that will compute that. So you have to approximate it with a polynomial, a Chebyshev polynomial or something. Fine. So there was a thread about this is an ATA and never use it. And because of that, motivated by that, I realized that someone said, I was saying, well, if you are using an ATAN arctangent in your code, you are probably doing something wrong. This is a code smell. Probably you didn't need it because probably it's going to be followed by a cosine or a sine, like an inverse trigonometric followed 5 lines later by a trigonometric. They kind of cancel out each other, most likely, with some noise in the middle that maybe you can convert. And someone was skeptical of that, so they told me, how do divide snap a vector to a quadrant? Like you have a free moving vector. Let's say the user is moving the mouse and you want to snap it to the x, y, and z axis, or maybe the 45 degrees diagonals. You need to do an arctangent divided by 4, do the floor function, convert it back to polar coordinates. And I was like, no, it can be done. So it was a challenge. Fine. I go to Shadertoy, I do it, I prove my point. You can do it super quickly with just a couple of if statements, no trigonometrics involved. And I was so proud, like, haha, I did it, chink, put it there. And then a few minutes later, someone goes in Shadertoy and makes a one-liner that does the same thing that I was doing. And it runs 1.5 times faster. And I was like, wow. So those moments are amazing because it's like I spend, like half an hour here or whatever it is, like doing this thing, optimizing it, commenting it. It's like my little piece of work of the day, the thing I
Yeah.
feel proud of today. I made something. I'm a maker. If I don't make something that day, it's not a good day. So I made this thing, happy to go to bed, and then someone comes and makes it so much better and quicker. And yeah, it was awesome. So um, yeah, Shadertoy, I go there because of that every day, and it's super cool. I don't know what the question
Okay.
was, but yeah, I have a
No,
lot of joy. I get a lot of joy from it.
all right. All right. That's awesome. Now for the Adobe part, which is also an interesting one because Adobe is not well liked company as well. So we're gonna have to, I don't want to do sort of drama here, but I'm very interested in your role. What do you do at Adobe, and how do you? Because you mentioned that you have a mission of like helping
Yes.
creators create.
Hmm.
So what is your work at Adobe, and how do you do this?
Yeah. So my job at Adobe right now, um, It's morphing, actually. It's in flux. But I did start 2.5 years ago, um, to resume the basic premise of Quill that I was talking about, which is let's use GPUs to enable more creators, not to make the current creators uh, make better images. Let's try to go wide, not tall, in that distribution. So I I joined to bring all the learnings I had from Shadertoy and from the demoscene and from Pixar in terms of using procedural content and sign distance fields, which is all these mathematical formulas that that allow me or that allow people to create shapes and graphics. Let's bring all of that, and instead of packaging it as a hard-coded version, which was Pixar, or as a low-level tool, which is Shadertoy, or as a painting tool, which was Quill, let's go to where the artists are. And the artists, in that distribution, in that Gaussian of artists, the long tails are in, it's not the 3D people, it's the 2D people who are doing, again, Illustrator and Photoshop and whatnot. So, and you have 10, 20x of those. So let's go after them and meet them where they are, which means they don't know what a 3D camera is. They don't know what a vertex is, what a 3D mesh is. They don't know what a texture is, what lighting, what? They only know colors. What is the color? No, you have to explain to them otherwise, right? Like you will have to tell them, no, the color is, well, the material, which can be a texture or can be a network, and then that you multiply by the lighting, but it's not really a multiply, it's a convolution, and then the lighting has speculars and diffuse and ambient, and you can put a cube map, by the way. There is bounce lighting, and then all that is going to be post-processed with this gamma curve and all this tone mapping and the color curves. And like, what? But I want my color to be, 00, 40, 60, because that's the brand color that my client wants, because that's the identity of the brand of my. I want to make design for them. How do I put 00, 60, 40? Well, you can write a plugin in Blender, that post-processes everything. Good. So with the with the goal of getting rid of all of that and realizing that I myself had been, so I had to, I'm going to put here a break. I'm going to do a push. I'm going to do a function call and then come back and continue. So I'm going to, the subroutine now is, as I was saying earlier, this artist we had in Quill, she was able to create 3D content for the first time in her life without ever using a technical tool, just drawing. Okay, data point one. Data point two was without being, I've never used Maya. I don't know how to model. I mean, I know, but from seeing people, I know the concepts, but I have never developed the skills to be able to build anything in Maya. But I was able to create mountains and a character and a lot of things in Shadertoy and elephants and dolphins and whatnot, just by smashing simple shapes together, like ellipsoids, and twisting the ellipsoid with a parabola to make it curve, and then attaching a triangle, which I smoothly blend to make the fin. So all those higher level ways of modeling, as I was saying earlier, instead of doing polygons with these mathematical SDFs and primitives, you can think in higher level, in volumes and shapes, and you can explore things very rapidly. Because again, if you put polygons together and you don't like it, you have to start moving vertices, smoothing things again. But with primitives, with parametric primitives, you just move things around and everything reconnects automatically, right? All the shapes blend and smash together without polygons. So you can very quickly iterate ideas and explore. And even if you're not very creative, just by serendipity and by the fact that you are exploring such a vast space very quickly, you end up finding good designs. I always say I'm not an artist, but I know how to avoid ugly things. So when I do my shader toys, I just keep trying things until the thing looks good. So that exploratory ability came from these SDFs. So that was the second data point. I'm not an artist. I'm not a 3D trained modeler. I don't know how to use Maya, yet I can do 3D content. Just like this artist was able to create content without ever having touched a digital content creation tool. So, okay, pop, we go back to Neo. So the point was, okay, let's do the same, but for the 2D artists that are Adobe's natural clients. And so we have to go use all these techniques, SDFs, no cameras, remove all these UX things that are necessary, and convert them or remove them and give them something that they understand with the paradigms and the workflows and the mental metaphors and mental models that they have been using for 30 years when they do 2D content. So that's where we are. That's the mission. And we have succeeded in some fronts. In others, we are still working on it. And it's super fun because, again, it's using technology not to make better shadows, but to how do we enable another 10% of users? How do we make them succeed and make the first 3D stuff for the first time? That then eventually they will print in 2D, right? But instead of having to, when you see a 3D logo or some isometric drawing in a billboard in the bus stop or something, it's most likely a 2D designer that drew a grid of hexagons in 2D and started tracing lines through the hexagon grid to fake 3D because that's what they don't know how to put a cube in Blender and move it and then get a nice picture out of that. So if we can get another 10% of users to use 3D, even though the output is 2D, and be happy with it, that's what we should use our GPU and better algorithms and burn more shader code towards
Okay.
versus better values. So yeah, it's been fun, and the team and Dave Cardwell is a great leader, and the team is fantastic. So
Uh, how much can you speak in more detail regarding the products and like how does this fit into the actual thing? Because you talk about the idea, but
right,
not the
yeah,
implementation.
okay. I mean, I cannot give too much details, but I can share for sure that it's a web application,
Okay.
um, which already comes with a lot of constraints. So you know, so when you start with an idea, what you were saying, the options are infinite. Like you can do anything. The possibility space is huge, but then and the problem sometimes is that it's so big that you don't know what to do, how to go, what the product is going to be like. Sometimes you might even be paralyzed about how do I start? What should I use? You start building infrastructure and putting technologies together without a concrete goal. I like more like working backwards, like doing a prototype that the user uses and give us feedback and then build technology and abstract backwards from there versus guys, give me 1 year of engineering and I'm going to build an amazing system on which we will build the thing. I don't do that, right? So, but in order to start building, because the possibilities are so large, you need constraints. I think this is a bit of a pet theory I have, but you need constraints that kind of collapse the wave function and gets you super concrete, a little seed from which you can start growing everything else. And sure, you will modify it later, but you need some event that. So for us, the event was WebGL, meaning we want to be in the web because we want this thing to grow um, organically, right? Like you want a designer to discover the product and just sending a link to a friend, like, hey, look what I did here. And the other friend clicks the link and now they are in the app. Now you have two users. You don't have to send marketing mails and all that. So web was a constraint. And that means that we are trying to invent the future of 3D, at least a future for 3D. Some of the users, I think the film people and game people will keep using their stuff for sure. We don't want to get rid of that. But many people will be doing 3D in the future with technology of the past because, sorry, I just dropped something. WebGL was made in 2009. That was WebGL 1. WebGL 2, I forgot when, 2019, who knows. But if you look at the specification, it's basically OpenGL 3.0, which means it's right after multi-texturing and transformation and lighting in hardware, but you have shaders, basic shaders, but you don't have compute. You don't have SSBOs to put large amount of data in memory. All you have is uniform buffers with 64 kilobytes. So our data has to fit in 64 kilobytes unless you bind and unbind things all the time. So no tessellation, no ray tracing, not a lot of things. So it's like it's it's like the demoscene kind of thing where you are super constrained by all these limitations, yet you have to create something amazing. So that's been the fun challenge. So that's for the rendering part. Um, the engine is written in C++, and sane C++, C++, and all that. Um, and then we have a great team doing backend work as well to be able to serve all this project, all this content, and making the UI and all that. Yeah, probably I cannot go much deeper than that, but yes, basically WebGL. And of course, um, it's sign distance fields, meaning again equations. In the end of the day, the user doesn't see that, right? For the user, it's just high-level primitives and shapes they drag and drop. and they control how all these shapes blend together, how they colorize the surfaces and whatnot. But internally, it's all math. There's no data, as in meshes or anything. But then, um, when you are in Shadertoy and you do these things, you might use a lot of um, tricks. For example, you can use a sine wave to create an infinite amount of bumps, right? If you want some hills to go forever, well, a sine wave is that one function, one function, infinite number of 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 hills or bumps. Of course, you can add a second one to distort them and so on. But basically, there's a very often we do data expansion, let's say, or like very little description creates a large amount of of visual complexity. But that's a very technical skill, and we can find ways to expose that to the artists. But if we can avoid it, we will. Which means that to the artist, when they see three bumps, they don't think of a one sine wave. They think of three bumps, and they will put three blobs in there, three spheres. So, and all that to say that, um, unlike the SDFs, you might see in Shadertoy, which are very optimized by very technical minds, the SDFs we have to deal with are very, very complex in terms of how many primitives there are, how many math has to be executed. So we have to do some very creative and interesting optimizations in terms of, as you can imagine, from data partitioning to space partitioning to uh, also low-level tricks, closer to the hardware as close as we can get from WebGL. But there is all a large spectrum of optimizations, algorithmic, mathematic, programming. So it's pretty cool, and the team is great. We have Anton K coming from Dreams, the game in PlayStation. So we have a bunch of gamers. We have also more traditional C++ app developers. Um, yeah, but it's fun. Um, so that's where we are.
It seems like a place where you would learn entire WebGL to the limit and then how to hack it.
Maybe we are very intimate with how it compiles. I mean, we don't use the whole API because again, we don't do meshes, so we don't have to do draw array instance or anything. Just draw a quad. We don't draw a quad in the screen, but basically we just draw dummy polygons, and then there's a shader. So we don't use the whole API, but we are very intimate with how different browsers compile the shaders and what are the tricks and to cheat on them and make them do the thing we want. Yeah.
I find it super inspiring that you joined Pixar and this was where like there was a goal to make this movie and people told you like and you soaked up the knowledge from people there and then you developed your skills, but you also had this like your idea of like doing the math from the demo scene.
Yeah.
And now you're at the place where sort of you are realizing your dream within the company that is best suited for this dream. Like this is from sort of like, oh, I'm learning here to now like I have this grand idea. I found the best company to do it, and let's do it together through the company. This is
Yeah.
super cool. This is super
Yeah, it's
awesome.
cool. I love it. I'm very lucky, of course. Although I would be lying also if I didn't say that I wish I didn't have to work and I could do my YouTube videos all day. That's my little dream,
So
to teach people about how creative and artistically creative you can be with math and how you can make those boring things that because most people, when you tell them what's math to you, they will say something like, well, accounting and maybe engineering, maybe statistics. But it's kind of these very mechanical applications. Well, mathematicians will kill me if I say mechanical, because mathematics is probably the most creative field humans have ever engaged with. But for the most people, it's engineering, mechanical things, and statistics, and so on. But there is all this field that many game developers and film developers use from mathematics, which is just purely aesthetic, and they put math equations together to solve problems, lighting problems, motion problems, whatever it is. And I want more people to know about that, if only for them to give a second chance to exploring what math is when they are younger. And I have given talks and so on about this topic. to not a great success, but I still try. And the YouTube channel is one more attempt to do. I'm not trying there to teach math to anyone. It's not an educational channel. It's more like inspirational, perhaps, where I just want to expose that this thing exists. I don't want you to necessarily learn how to do it when you watch the video. I just want you to know that this can be done. These are some links, resources. Go ahead and start your own journey, perhaps. So that's what I want to do. But I have to pay a house and all these things. So I might as well have a lot of fun while I pay the house and go to Adobe and do this little dream of mine. But the other bigger dream is the YouTube channel. Well, it's a YouTube channel for now. In the future, it can be a tool that schools use to educate kids or to help them get a more intuitive feel for all these things they learn in mathematics. Because in the end of the day, I think it's all about when I apply all these maths for shaders or, well, I'm talking of me, but any graphics programmer who is out there, optimizing an engine or who is at the frontier of their game, or any filmmaking, every technical artist in a film studio or animation studio is going through the same things. And all these people have a very intuitive sense of what squaring a signal. A signal is just a set of values over space or time, right? So what squaring means? Oh yeah, well, anything that is close to zero is going to get down to zero. Anything that is higher is going to spike up. You're going to create this very sharp comb shape profile to what before was very smooth and blobby thing. And I'm going to logarithmic. I'm going to put a log to the domain, so the whole thing compresses on the left and then slowly slows down, or whatever it is. There's all these intuitions you develop by playing with the math in form of graphics or sound or motion. And I think I haven't seen a tool yet. Now my kid is 7 years old, 8, and I try to. We are still trying to keep her away from screens as much as we can. But the one or two things we let her do digitally have to do with creative tools like that. And I've been researching a bit, and there is not much. There is things like Scratch and so on, which I don't like. I'm gonna make another friend here. I don't like the Scratch modeling paradigm. It's very object oriented in a way, but there's Scratch and a few other things. But there's no a tool where kids can go in and feel math in a very tactile or physical or visual way. And of course, not every kid will benefit from that, because some people learn by repetition or by storytelling. Others need movement, and they need to be in a space and move from left to right to kind of, get the thing sink in the brain. Other people really like to read a flat, boring, dry list of facts, and that's how they learn. Others, I was more of an intuitive, visual way. So I think some people at least might benefit from something. So in the future, I think after the videos, I would like to maybe try to do something in that space of making tools to make math more intuitive. Um, but meanwhile, I'm having a lot of fun in Adobe. Yes.
What did you learn from the videos you made? First of all, they're like extremely high quality and editing and like all
Oh,
of
high
that.
quality.
Like
Yeah.
this is like I can't imagine the effort of like 1 hour of this video to edit this and prepare this.
Yeah,
It's just like
those were mistakes,
stunning.
that cost me a lot of hair loss. And if I do it again, it will be with a different approach. I think it has to be. Yeah, I so yes, you're right. So these are videos. Some of them are very long. The longest one is 42 minutes of 4200 minutes of continuously animated content, high quality rendered, and a lot of explanations and formulas showing and disappearing the screen, connected to what the visual is doing at the time. So basically, walk people through the whole process of going from a white canvas, where the color of every pixel is FFFFF, to starting typing the formulas and doing plots that eventually, over time, by layering more and more equations and more shader code, the complexity of the picture also gets increasing and getting layered. All the details get layered, and eventually you have a beautiful painting. Now, that whole thing takes 42 minutes because I give explanations, not of exactly how everything works, again, because I'm not trying to teach, but just giving hints as well. This works because of that, and this is what I did here. Because I needed more saturation, I took the colors and I don't know, subtracted them from gray, took the difference, multiplied it, and then applied it back. So the colors would move away and separate for middle gray, whatever it is. Actually, I didn't do that. So I give explanations at that level, and the whole thing is animated, and it took forever to make those ones, especially. So actually making the visuals themselves, the final piece, let's say the mountains, is one of the videos is a landscape. That maybe took me like a couple of days. Making the video is 2 months or more. One of the videos took 6 months because I also don't have the time to. I do it when I can, and most of the work was in scripting and also recording because now I'm getting better, but uh, English is not my first language. And especially at the beginning, I was super self conscious of all the mistakes I was saying and how weird my accent sounded and how the intonation wasn't right and how it felt too robotic or too weird or I was speaking too fast, which I do all the time. So it was super painful to come up with 42 minutes of audio that I was happy with. And that's the longest part. And then synchronizing the pictures to the uh, animate. So the whole video is a shader. It's a shader toy. So the whole video is one shader toy where I loaded my voice in a soundtrack
What?
and I just start typing. Like if I want this graph to start fading in, I go to the line of code 3045 and I do alpha equals smooth step of 0 to 0.5 of time minus 250, whatever. And I do everything like that. And which is great because it allows for super crazy transitions that you wouldn't be able to do in a regular editing software where I can take a 2D graph and suddenly whoop, it morphs in a 3D thing and it does super
Yeah.
weird things. But all that spectacle that doesn't really help that much
Uh,
with the method that math is fun. So I overcomplexify my life with all these high expectations for the soundtrack, for the voiceover, with all these animation tricks that I didn't need really to bring the point across. And then rendering is also the fun part because it's 42 minutes of content, so that's a lot of gigabytes of HD frames that they have to generate. And of course, in Shadertoy, everything's real time, but for the video, I crank it to 11, right? So I put a bit more super sampling, I slow down the ray marcher to make sure there's no artifacts and all that. So render time can take maybe a minute per frame or something. So now you count 42 minutes times 60 seconds times 60 FPS times a minute. That's a lot of hours and days. So actually, that video of the mountains was rendered in California while I was in Korea. I went to live to Korea for 4 months with my family when during the pandemic because everything was shut down here and we were so bored here. It's like let's go there, and there life was normal in Korea. Everyone was wearing masks, but I saw more people my first week in Seoul than I had seen in the last year in San Francisco. Everyone was out. It was amazing. So we were there, but my computer was here in San Fran, um, cranking
burning.
frames, and I had this connection. And then I was transferring files to my laptop in Seoul through FTP, and I did the final MP4 baking in my poor laptop in far from home, and that's the one I uploaded to YouTube. So the whole thing took forever, and I was so mad because the last few days or weeks was just polishing little things. Like it's 42 minutes, so when you watch it, it's a long time to watch. You have to watch there is no mistakes, right? Like the right formula is showing at the right time, that is properly synchronized, that you didn't make a mistake, that there's no a minus sign somewhere, whatever it is. And 42 minutes is a lot of content to review. So and still, I uploaded a version, and just 10 minutes later, I watched it, and I was like, "Ah, mistake! It's already uploaded. Too late." So the video has a couple of mistakes in there, but I'm
I
not doing that
think.
again. I think now I started making shorts for TikTok and Instagram, and actually that's going relatively well. And it's a lot lower effort. I can record one of those in an hour and just upload it, lower stakes. And they are not really inspiring that much, but I'm hoping to grow some followers there, so I can redirect them to the next big YouTube video, which I want to do soon. I have two ideas, and I'm hoping to keep the fire alive through TikTok and Instagram
Okay.
with lower quality, easier to make videos, while I build time and budget to make the next big video on YouTube.
How many hours daily do you work?
How many hours a day?
Yeah.
Uh, I don't know. It depends. Uh, Not that many. I'm getting older, so also, well, no, that's wrong. It is true, but that's not the reason. The life is more complicated, right? Like you have, uh, I have a kid, I have family, so my, I cannot work in the weekends. I cannot work on my projects in weekends. Basically, maybe one weekend if the kid is going to someone's birthday, maybe, and I'm not the one taking care of going there, or the soccer game Saturday morning got canceled or something like that, then I can have some time. But if I have time during the week or the weekend, it's always fragmented in very small, like 1 hour here, half an hour there. And I don't work well that way. I work well by, going to a rabbit hole and spending hours. So the only way to do it is at nights, 1 to 2 a.m. or 1 to 3 a.m. But that means the day after I'm going to be destroyed. I can no longer do the. There was a time with Paul, uh, Jeremiah's my co-founder in Shadertoy, where we would go. It was 2011 when I was at Pixar. Every night, no, sorry, 2 nights a week for a whole year, we would go to uh, clubs at night in San Francisco and bring the laptop and connect it and play visuals to the music that whatever DJ was there was playing. So we built our network of contacts, and we were going twice a week. And actually, that's where much of the idea for Shader, I forgot to mention, much of the idea of Shader Toy came from there as well, because we were playing, our tunnel effects and deformations and meta blobs, all that synchronized. And we had this software we built on our own in C++ and OpenGL. But one of uh, the most successful visuals we had was one where we had an effect and the code on top of it, and we would live coding the effect. So we had some input signals to the shader through textures like the FFT of the sound and the time and a few other things, and then we would start live coding. And being San Francisco, like half of the audience were fellow nerds who knew what was happening in the screen. So it was super fun to twice a week being there coding and live coding all those uh, shader effects and all this. I guess to say to that, we that was fine. I could be twice a week going out at night, going back home really, really late, sometimes going straight to Pixar from the gig, and still be fine. I could handle it, and no drugs, no nothing. It was just strong enough to do it. Now, one day I go late to bed from making a stupid arctangent divided by 4 shader. The day after, I'm not productive anymore. So I try to limit that as much as I can. I try to control myself. And then, yeah, on top of that, life is my brain is super fragmented, and of course social media doesn't help. But you have family and things, and I have family in Spain, family in Korea. They need things, we need things, there is daily life things. And also when I leave work, I'm fully for my kid. Like, she's at school every day, so I don't see her, right? So when she comes home, I stop everything I'm doing. I'm super hyper focused on her. We play things, we explore ideas, we climb the tree, with all sorts of things. And so I want to be there for her, but that means a big context switch from work to that. And then putting to bed is a whole battle on its own, putting the kid to bed. Then context switch to do the finances, the doctors, the family, whatever it is. Wake up in the morning, Quill, Neo at Adobe. So it's all like fragmented, and it's difficult to do what people can do, or I could do. At least I was lucky enough when I was younger that I didn't have to take care of family or anything like that. So all the time was for myself. And yeah, not even girlfriend at some point. And it was fantastic to be able to, close the door and spend the whole weekend from leaving Pixar, and 5 p.m. or whatever until Monday 9 a.m. non-stop, 50 hours of rabbit hole into an idea. And those days are gone. So I'm hoping that one day when the kid is 18, maybe I will
They
get
come
my.
back.
It's funny because when you are a kid, your time is not yours. Your parents determine what you do, where you go, whatever. When you're a teenager, still as well, and then you finally gain freedom with your first job, and you go there, and your time is yours. You're in full control, and then suddenly you you are back to being a kid, because my time is mine. but it's not only mine; it's also my family's, and that's fantastic. But there will be a time where I hope my time will be mine again, and but then I will be sad because I won't have the kid around me to give me all this energy
Yeah.
and all the things, fun things I do. So I don't know. I guess uh, maybe if you probably there is a reason most people do their best job when they are in the 30s. It's probably not. I don't think it has to do with kids or not. Probably it's have to do with that ability to hyper focus on something, being younger and more energetic. Although many of my colleagues are my age and they are doing amazing work as well. So I don't know where I'm going with all of this. I'm rambling. Sorry.
All right. Uh, I want to ask you, what would you
Mm.
say as an advice for people that are starting out now, especially with the
Mm.
LLMs out there, uh,
That's so funny. Just yeah. Go ahead. Sorry.
to just like, if
Yeah.
somebody admires you and your work, what to do to become you at some point?
Um, well, I don't know. Becoming me, that's a good idea. Everyone live their own thing and find their own. Uh, this like life is like a theater. You have to play your character and find who that is. But I think okay, that came too philosophical. So yesterday, actually, I just gave an advice yesterday to someone who wanted to apply for a job, and uh, this person had amazing scores and some very good results in some of the coding Olympiads, which I didn't know existed. I knew about the mathematical Olympiads and all that. There are coding Olympiads as well, where they are told, "Oh, you have a text file with all these lines of code which represent how many horses are in the stables, and can you find how to pair the horses so they don't blah." Anyway, very good scores and all that, but um, I gave them some advice to yes, they can apply, of course, and they should because they were very good. But there's nothing like building something in your spare time if you have if you have the luxury of having spare time as a student or as a grown up, and if you are going to apply to a job, for example, as a hiring manager myself, I don't care too much what's your diploma. Just show me that you have the passion to go for a project and that you can architect it from scratch, that you know what the problem is that you are solving, that you know how to ask the users what they want, or if you are an artist doing something more creative, like a game or telling a story, that you know how to make that happen, how to get rid of the bad ideas, synthesize it, iterate it, and then build a system with all its parts. It's very easy. Okay, it's not easy. One thing is to find the solve the queen's problem, the chessboard with some recursive algorithm. It's a very local focused problem to solve. A different thing is to think in systems level, where you have all these pieces, moving pieces, how to connect them together, and you can show that by building something, building a game. It has many pieces to it that have to interact with each other. How you choose your libraries, how you choose what to reuse from someone else, what do you choose to do on your own, and why. So if you can build something, it can be a game, it can be a shader toy, it can be a product, an app, a service. That's the best thing you can do probably if you want to find a job and so on. I think that's one. The other one, maybe I've never. I mean, I don't know if I can justify this, but or give it like uh, this might be counterintuitive maybe for many people, but I like reinventing the wheel. I think we are training engineers and programmers to not reinvent the wheel. There's always this thing like, why would you write this if there's a library that does it? Well, there are many reasons, practical reasons, in order of the complexity of your build system, dependencies with another team that might be in charge of that library and have many clients that doesn't have your interests. Your interest as their first priority. There's many reasons to use it, and also many reasons not to use it. But regardless, if you reinvent the wheel, you are going to learn so much about how that thing works, and you are going to maybe invent the next iteration of the wheel. So I don't know why we are so much trained to not reinvent and just layer libraries on top of libraries and abstract things on top of things. And if there is a complex thing you don't understand, you have two options. You can put another layer on top with a few things you understand from it and expose only the things you need and build your own framework so you don't have to learn the one below. But now we are in the layer over stack, layer over layer over layer, and we have the whole stack of inefficiency there and complexity. Or the other option is just in Spanish we say like take the bull by the horns, which means don't work around it. Just go there, deep dive, and get it a chance to learn in it and reinvent it, perhaps, or modify it for your needs. So I don't know if that's a wise advice, but that's what I've done, and it has worked for me. Like when I was at Pixar, I would deep dive in RenderMan and see how it works, and that's how I learned all about the dicing mechanism and the rendering and the micro polygons and all that. So yeah, reinventing the wheel is good. Um, and then I don't have more advice other than what I can say is that I think like most people that I know that they like what they do and they are good at it, they are more often than not they are obsessive about it, and I'm certainly that, where there is this plan in my head and I cannot not do it. And sometimes life puts me obstacles, right? Like, and I have to wait a bit longer to be able to execute or to learn some skill that I need. But the talking about math and making people know that you can use creative math creatively, this is coming from that one butterfly in 2000. So it's been a 25 years thing, and I'm still stuck into that. I'm still like, one day, I will be 80, but finally I will be able to make this video that I want to make and show the world. So I'm super stuck into that thing, very obsessive, and also in that's bigger picture, but also locally, like deep diving into one shader and staying there for 1 hour trying to optimize some ridiculously small and useless piece of math.
Yeah.
That then proves useful because then I see that that I need it for Neo or for Quill or for some product. I'm like, oh, I've been there. The more of those exercises you do, the bigger your data set it is for them recognizing patterns and finding things. So obsessing over things has worked for me. It's probably not healthy, but it has some benefits. I think society needs people who don't do it and are very good at people and relationships and feelings and all that, and then you need people who are obsessed about other things, and you need all these different functions for society to work. We are like a big organism, I guess, and cells specialize. Some cells are an eye and another cells are a kidney, and I think some people are the obsessive person, some people are the people person, and we all play a role, and mine has been the obsessive one. So
All
yeah, I
right.
don't have advice. Yeah, that's what I do.
All right. Thank you so much, Nico. This was super cool. It was super awesome. And
Thank you.
we
You
should
have been
do
like my therapist.
we should do like at some point in the future like a part 2 where we go like heavy into math, like heavy into this function, what it does,
Yes,
this
I think
function,
that would be
like
easier if I can pull up pictures
yeah,
and share videos and pictures and maybe do some live coding.
we can do like an
Because just
interactive.
verbally, I didn't want to go much deep into math because verbally it's difficult to
Yeah,
talk about these
yeah,
things.
yeah, yeah.
But
But
yeah,
we can do a session with you sharing the screen, and I will be this like student, and you'll be like, your job would be to teach this to me and convince me that this works, and I will be like, but what about this? But what about this? This would be the
sounds
part
good.
2.
Yeah, let's do
All right.
that.
Thank you so much for joining me today. This was awesome.
Thank you. Thank you. I had a lot of fun.